What's good? What's good? What do we got for this week? Star Trails. What do you want to do? We didn't even finish Coriolis. These guys, Pfinky and West are on the way to learning on how Coriolis works. If I had like a few hours with them, maybe. It's tough when you're trying to teach someone something. They're just fighting you the whole way, going against what the thing you're trying to teaching them is. Like, I don't know if it's even possible, but I think they're coming along.
They even go against their own model. I mean, the way it's actually. I mean, they go against the actual grain of the Coriolis, but
They're going against the whole shit, bro. They're just like way off. It's crazy. I don't know. I think I made a breakthrough with Pfinky though, because he was like the path and the inertial and the non-inertial frame were the same. He was like laughing and thought I was nuts because they're different, but then I showed him how they're different. So he might have had a revelation or something. I don't know. We'll see. They ever come in. If they come in. Depends on when they come in too. Like if they come in and somebody's going off on some bullshit and then I don't know, stuff. What do you got though? What's new? Anything new? Yo, did you see that guy's hilarious? He's like, I'm not. Did you see that TikTok I sent you? He's like, I'm not casing the joint or anything. He's like, where did them wires go? Bro, that guy, I follow that guy.
I like watching
Yeah,
his videos.
that guy's hilarious, but that one actually had me tearing up and shit. It was so funny. He's like, I'm not casing the joint. Guy's like, what? That guy makes so many people pissed. His wife even called the cops on him and he started doing that to her.
No way.
Yeah, that guy's wife called the cops on him. He's like, he's being a maniac. It's too funny, dude. That guy's nuts. He pisses people off so much. Some guys are cool and they laugh with him and stuff, but some dudes are getting heated about it. The one guy's like, yo, you want a fresh one?
You seen the guy that was like, the black guy that was like, I'm a risk taker. Like he was ready to fight him.
Yeah, he's like, what am I looking at here? He's like, you're looking at a motherfucker that's willing to take risk. He's like, so you're saying you would pick up the soap if you were in. Yeah.
I know it'd be a pain in the ass.
Bro, that guy it's too funny, dude. I gotta get that MIT, I think it was. They did a great description of Coriolis. I gotta pull that up and do a PowerPoint presentation for the Globers so they can realize how it works and what's actually going on and shit. Because otherwise, you're just arguing against you can't argue against somebody that doesn't know the thing they're arguing about. I mean, I can do that because I'm nice like that, but
Like I thought, Bacon would actually know the difference. He's talking about a train track.
no, he's the worst one, bro. He's the worst one. Have you ever heard the six? You know the leading the target. This is the leading the target argument. He talked me out of it. He talked me out of it 2 years ago, and then for 6 months, I was just off it. And then I thought about it again in my head one day. I was like, nah. I was like, I'm right. I'm definitely right. And then I brought it back. But yeah, he did some half-ass animation thing a while ago. Nobody knows how Coriolis works, and they all want to debate Coriolis. This is wild, absolutely insane.
Which part of it do you reckon they misunderstand? Like all of it or a specific bit?
All of it.
Like people not knowing what the path is, that is wild. That's absolutely insane to me.
So you fully cut out for like 15 seconds.
I said people not knowing which one is the shorter path is wild. There's people running around thinking that if you turn, you took a shorter path. It's absolutely, there's no point in going further than that because that's ridiculous. That's not even Coriolis either. That's just basic, like basic facts about reality and shit.
Do you reckon, is there like a specific part where they're going wrong that gets to the wrong answer? Or like is there one thing they're missing?
Yeah, the part
or
where they
something?
say if you turn, you took a shorter path, or it's unknown which one the shorter path is. But we know one guy's turning and one guy's not. So like, we obviously know which one the shorter path is. That's the part they're getting wrong, completely wrong. It's obvious.
But what flaw do you think we're making that leads to that wrong answer? Like, are we
About
misunderstanding
not
the
knowing if
atmosphere or?
it's nothing even about the atmosphere. It's turning or not turning. People think that turning is a shorter path. That's absolutely insane.
Yeah, but I mean, like, what mistake, are we making that
The
gives us that
mistake when
conclusion?
people think the mistake that people think when there's when you're turning, you've taken a shorter path than the guy who doesn't turn. That's the insane part.
No, but
That's
as
the
in
mistake you're making.
what factor of the Coriolis are we misunderstanding that leads us to that conclusion?
Well, that's before you even get to the Coriolis effect. You don't even have to talk about Coriolis effect. That's not even relevant as far as this first part goes. The shorter path thing, that's not even, that's regardless of Coriolis. The guy who turns left took the shorter path, obviously.
Yeah, I would agree that by default. Yeah.
The parts about the Coriolis that they're getting wrong is not knowing which frame the shorter path is. They're getting that wrong. They're getting the forces wrong. They're getting all kinds of stuff wrong. There's people running around thinking that because the atmosphere rotates with Earth, that the Coriolis effect somehow now isn't the Coriolis effect or something. Like, it's wild.
Would your speed over the ground towards the equator, would that have to vary to keep up with the Coriolis trajectory? Like if you're treating it like a bullet?
Nope. You can go as fast or as slow as you want over any path on the ground.
Yeah, but that's the thing. Planes can't do that. They're limited to a top speed in the air.
Yep. And they can go as fast as or slow as they want. They can go 500, 400.
No, because like
Nothing's
if you
dictating. Nothing dictates the plane speed, but the guy controlling the plane. So
if you have a plane flying the Great Circle route at 600 miles an hour and another plane 600 miles an hour following the Coriolis, that one has to go way faster than 600 miles an hour over the ground at some point to follow the Coriolis trajectory, because he's not aiming straight at the target. So because he's going diagonally, he's going at a slower speed towards the target if he
So
were
if
to
he claimed,
go the same speed over the ground.
yeah, like
is it?
that's the
I
shit
suppose
that's wild. That's the shit that's
is he
wild that you
claiming?
can get. What's up?
I'm just saying, like, is he claiming that the Coriolis means that the Earth is moving underneath a flying object?
I don't know. Let me just point out the thing he got wrong just now, though. That's another thing you guys get wrong, is you just said they're both planes are going 600 miles an hour, and then you think for one plane to take a different path, that you think there's some path where a plane can't go 600 miles an hour. That's wild. It's just
No, I'm saying they have to go more than that.
Gibberish. It's gibberish. Nope, a plane can go 600. If a plane's top speed is 600 miles per hour, they can go 600 miles per hour in any direction they want. They can turn, not turn, go left, go right, diagonal. It doesn't matter. That's another part you guys are getting wrong. Just keep talking and I'll point out every time you get something wrong.
Okay, do you agree that if you're not aiming directly at the target going 600 miles an hour and another plane flying the Great Circle Route is aiming at the target, then your movement not at the target at 600 miles an hour is moving less than 600 miles an hour towards the target? Yeah, like if you're going diagonal.
Over the ground, the
towards the
plane can
target.
go any speed. Towards the target, over the ground, a plane can go any speed they want in any direction they want.
Okay, imagine a plane flying south at
Still
600
wrong.
miles an hour to the
You're
equator.
still wrong.
Yeah, okay, now imagine a plane flying southeast towards the equator at a 45-degree angle. Would you agree that plane's going less than 600 miles an hour directly south? It'd be going 300 miles an hour, right?
No, a plane can go 600 miles over the ground or 300, however planes
I'm not
work, they
talking
can go
over the
whatever
ground.
speed. They can go
I'm talking
whatever
towards
speed in
the
any
equator.
direction. Blah. What's up, man? Can you hear me talking? Can you hear me talking?
Yeah, you misstated. I said over the ground. I didn't.
Yeah.
I said south towards the equator.
Yeah. What are you measuring the miles per hour against? What exactly are we measuring the plane speed?
The air and the ground.
Which is rotating with the ground. So the thing like you're interrupting me for no reason, like you're wrong, and I'm trying to correct you on how you're wrong, and you're interrupting me, not wanting to hear how you're wrong. Like it's crazy. Like that's what I'm saying. You can't teach people things if they're fighting you the whole way. It's impossible.
But you completely misstated the argument and then based your entire rebuttal on that misstatement. So the answer was different.
Nope, you just agreed with me. The ground, the air, 600 miles according to the air. So that means the air is moving with the ground. So it's going 600 miles according to the ground. A plane can go any speed it wants over the ground. That was your whole objection, was not the ground. But now it is the ground. Like, bro, this is like, I don't know.
Okay, would you agree it's all
fucking crazy?
The same speed through the air?
It's like
the
nonsense.
Same as the ground. If there's no wind, would you agree that it's always the same speed over the air and the ground?
They can both. Yep, you can go any speed. A plane can go any speed it wants within how flying works. Yeah.
Do you agree a plane can only go up to its top speed?
Given that a plane could go, given that a plane can go anywhere in any direction it wants, any speed it wants, that's within the reasons of the plane. So you have no argument.
Okay, so again, is a plane flying
You're trying to argue with shit you don't even understand.
Okay, is a plane flying southeast at 600 miles an hour heading towards the equator at 600 miles an hour or 300 miles an hour?
A plane can fly whatever speed it wants to fly. If you have two of the same planes, they can go in any direction and fly at the same speed they want. There's not some magic direction that doesn't let you fly the speed another plane flies.
You're not. Okay. Imagine a plane flying east along the equator at 600 miles an hour. Would you agree they're traveling north at 0 miles an hour?
Fucking stupid.
It's fucking stupid, bro. I know. Like I don't even know.
Would you agree they're moving north at 0 miles an hour if they're traveling?
He's just got dumb questions. How about you tell us something instead of keep asking stupid questions?
But it should take you 5 seconds to give a one-word answer to my question. If
you keep asking the same thing, man. Like, tell us what we don't know.
You still haven't answered it. You haven't answered the south question at all. So I'm making it easier with the east along the equator. Would you agree you're moving north at 0 miles an hour?
A plane can fly south. A plane can fly south at a certain speed, north at the same speed. Any speed the plane can go, it can go in any direction it wants, that speed.
Okay, I'm talking about your closing distance to a target that you're not aiming at. Do you get that? Do you understand what I'm trying to say?
Yeah, so if I'm heading south, if I'm heading east, I'm not going towards north. No. Well, it depends on which way you're coming. Hold on, it depends on which way you're coming from. Because if you're going east, In the south, you would be getting closer to the North Pole.
Well, no, I'm aiming east the whole time, flying along the equator.
Yeah, if you're aiming east and going, if you're traveling east, you would be getting closer to the North Pole. You can't go east and not get closer to the North Pole.
Equator.
If you're in the southern hemisphere.
On the equator.
If you're on the equator, then yeah, you're not going closer to north or south. Why is this relevant though? This is completely irrelevant.
Okay, so now imagine I'm on the equator. Okay, so you've agreed I'm going north at 0 while I'm aiming east on the equator. Would you agree that if I then turned northeast, flying 600 miles an hour, I wouldn't be going 600 miles an hour north? I'd be going less than that on a gradient from 600 to 0, aiming fully
if you're
east,
going
I go 0 north.
If you're going 600 miles an hour, and then you turn and go in a direction, you're just going 600 miles an hour in that direction now. Any direction you turn,
it's not north.
You're going to be going 600 miles an hour. Who cares? Why is this fucking relevant? Like, I feel like you're trying to just like make me mad by saying irrelevant stuff, or I don't know.
No, it's completely relevant because a plane aiming at the target directly going 600 miles an hour is closing to it faster than a plane not aiming that target going 600 miles an hour. Because you agreed you're not moving north at all if you keep going east, not aiming at north. Whereas a plane directly aiming north is getting to north a lot sooner than a plane going east, right?
No shit, Sherlock.
Okay, so now imagine that you're at the equator flying east.
I mean, this is just gibberish, dude.
Okay, so
this is fucking gibberish. Say something that has some kind of meaning to it.
Okay, so you agreed if I'm flying east, I'm going north at 0 miles an hour. Now I turn and go northeast.
Relevant, dude.
How much north am I going?
Who cares? It's not relevant.
It's completely relevant.
I can't talk to this guy. Carlos, if you want to have at it with this guy, go ahead. I can't. This is just non sequitur.
Well, he needs to tell us how the atmosphere is in lockstep with the Earth, and at the same time as it being in lockstep with the Earth, it's actually got another thing which is opposite to that, which is called Coriolis, and the Earth is moving underneath a flying object. So if you're going in a straight line, if you're going in a straight line on a tangent, like over the equator across different latitudes, you're going to be allowing the Earth to move underneath your plane. Is that what you're saying?
That's Jeremy's argument, that we can ignore that the atmosphere is locked to the Earth and fly like a bullet with no atmosphere, in which case he would be right, leading the target would be quicker than a great circle.
So then a balloon, a hot air balloon, would just sit up there.
The bullet's going through the atmosphere. The bullet's going through the atmosphere. The bullet has a path. Whatever direction that was, the plane can leave from that same direction and head in that same exact direction that the bullet did. And it cannot turn left or right due to the Coriolis effect. So a projectile's a ballistics path and a path a plane can fly could be the same path if they wanted to.
Yeah, if you could steer a bullet and go the great circle, that bullet would get there faster than the unsteered bullet.
Nope,
they both have
absolutely
top
not. The projectile, absolutely not. The projectile that's going in a straight line is the one not turning, and it's going a shorter distance.
It's closing the target at a slower rate than the bullet going the great circle at the target and steering.
No, it's going to faster rate because if they're both going 600 miles an hour, and the one has a shorter path to take, the one that's going to get there first is going to be the one that's a shorter path, and the one that doesn't turn right, like the bullet doesn't turn.
So you're roboting. I heard most of your argument. No, but okay, would you agree it's a longer path over the ground when you lead the target for a bullet than a great circle?
Yeah, but over the ground is irrelevant. We're not worried about over the ground. We're worried about what the plane's actually doing. I can show how the non-inertial reference frame is nonsense. Like if you had a drone and you go around really fast, or and inertial frame, and then in the frame of the merry-go-round, you can make it look like it went 100 kilometers. So you could throw a ball very slowly. You could throw a ball very slowly over the merry-go-round, and if you spun the merry-go-round fast enough, Now, it may look like you threw the ball kilometers. Now, we know people can't throw balls kilometers, so obviously that's not even close to being real. The real path is in the inertial frame when you throw the ball a couple meters or whatever. And we know, yes, people can throw a ball a few meters. We do have the power or energy to do that. What you can't do is throw a ball kilometers. Keep fighting me, though. Keep fighting me.
I didn't. When you were saying kilometer, you talk about a merry-go-round spinning super fast.
Yeah, the non-inertial frame. Yep.
And when you
Keep fighting
said
me on it, though.
kilometers, did you mean like as in through the air, the ball's going 6 meters, but a super fast spinning underneath over the surface of that, it's a longer distance? Is that what you meant by kilometers?
Yeah, in the inertial frame, the ball goes 6 meters over the merry-go-round. But in the non-inertial frame, you can make it look like the ball went kilometers. Now, we know people can't throw a ball kilometers. So that's obviously not even close to being real. It's completely irrelevant what happens in the not real frame. The real frame is the inertial frame where we know people can throw balls 6 meters.
Okay, yes. And now imagine on that merry-go-round, we now lock the atmosphere to it, so it's spinning around with it. Would it then also be going kilometers through the air?
Yep, this is Coriolis effect. The Coriolis effect, like, if you have the Coriolis effect, you have it. If you don't have it, you don't have it. It doesn't matter if the air is moving with the thing or not moving with this thing. It's completely irrelevant. If you want to say there is no Coriolis because the atmosphere is moving with the thing, that's fine. I mean, that would screw you on a lot of other arguments, but that could be an argument, but that's not your argument. Your argument is there is Coriolis. So knowing how Coriolis works with the inertial and non-inertial frame, it literally does not matter if the air is moving with it, not moving with it. You still have the two different frames with the two different distances, and the inertial one's still the more real one because you can make the non-inertial one. You could get under a merry-go-round right now and spin under a plane.
Yeah, okay. Would you agree that if the air is fixed with the merry-go-round, whatever distance it has to cover over the merry-go-round is the same distance you have to cover through the air? The same length of air you have to go through?
Absolutely not. Pfinky just actually got wrecked on this, and the distances are different in the inertial and the non-inertial frame. If they're the same, you don't have Coriolis effect. Like you guys don't know how this shit works, bro. And you're trying to like debate me on it. Like, are you trying to figure out how this works, or are you trying to debate me on it?
Yeah, I'm trying to. Yeah, be honest and free. Okay,
you're trying to debate me on it, or
imagine
figure
the
out how this works.
merry-go-round's not spinning; it's still, and the air above is still. Do you then go the same distance through the air as you do over the ground, over the merry-go-round?
There's no non-inertial. You gave me a scenario with no non-inertial frame. There's no Coriolis happening.
No, we're not talking about moon. We're talking about the distance in a straight line when it's not spinning. Yeah, and in that
there's
case,
no Coriolis happening. Are you trying to learn?
Distance? Yeah,
are you trying to learn about this, or are you trying to debate me on it?
It's completely relevant.
I can't talk to this guy. Carlos, if you want to have at it with this guy, go ahead. I can't. This is just non sequitur.
Well, he needs to tell us how the atmosphere is in lockstep with the Earth, and at the same time as it being in lockstep with the Earth, it's actually got another thing which is opposite to that, which is called Coriolis, and the Earth is moving underneath a flying object. So if you're going in a straight line, if you're going in a straight line on a tangent, like over the equator across different latitudes, you're going to be allowing the Earth to move underneath your plane. Is that what you're saying?
That's Jeremy's argument, that we can ignore that the atmosphere is locked to the Earth and fly like a bullet with no atmosphere, in which case he would be right, leading the target would be quicker than a great circle.
So then a balloon, a hot air balloon, could just sit up there.
The bullet's going through the atmosphere. The bullet's going through the atmosphere. The bullet has a path. Whatever direction that was, the plane can leave from that same direction and head in that same exact direction that the bullet did. And it cannot turn left or right due to the Coriolis effect. So a ballistics path and a path a plane can fly could be the same path if they wanted to.
Yeah, but if you could steer a bullet and go the great circle, that bullet would get there faster than the unsteered bullet.
Nope.
Because they both
No,
have top
absolutely not.
speeds
The
through the air.
projectile, absolutely not. The projectile that's going in a straight line is the one not turning, and it's going a shorter
But it's
distance.
closing the target at a slower rate than the bullet going the great circle at the target and steering.
No, it's going to faster rate because if they're both going 600 miles an hour, and the one has a shorter path to take, the one that's going to get there first is going to be the one that's a shorter path. And the one that does.
No, but okay, would you agree it's a longer path over the ground when you lead the target for a bullet than a great circle?
Yeah, but over the ground is irrelevant. We're not worried about over the ground. We're worried about what the plane's actually doing. I can show how the non-inertial reference frame is nonsense. Like if you had a drone and you fit merry-go-round really fast or slow, the drone will go very short path and the inertial frame. And then in the inertial frame on a merry-go-round, you could make it look like it went 100 kilometers. So you could throw a ball very slowly. You could throw a ball very slowly over the merry-go-round. And if you spun the merry-go-round fast enough, it may look like you threw the ball kilometers. Now, we know people can't throw balls kilometers, so obviously that's not even close to being real. The real path is in the inertial frame when you throw the ball a couple meters or whatever. And we know, yes, people can throw a ball a few meters. We do have the power or energy to do that. What you can't do is throw a ball kilometers. Keep fighting me, though. Keep fighting me.
I didn't. When you were saying kilometer, you talk about a merry-go-round spinning super fast.
Yeah, the non-inertial frame. Yep.
And when you said kilometers, did you mean like as in through the air, the ball's going 6 meters, but a super fast spinning underneath over the surface of that, it's a longer distance? Is that what you meant by kilometers?
Yeah, in the inertial frame, the ball goes 6 meters over the merry-go-round. But in the non-inertial frame, you can make it look like the ball went kilometers. Now, we know people can't throw a ball kilometers. So that's obviously not even close to being real. It's completely irrelevant what happens in the not real frame. The real frame is the inertial frame where we know people can throw balls 6 meters.
Okay, yes. And now imagine on that merry-go-round, we now lock the atmosphere to it, so it's spinning around with it. Would it then also be going kilometers through the air?
Yep, this is Coriolis effect. The Coriolis effect, like, if you have the Coriolis effect, you have it. If you don't have it, you don't have it. It doesn't matter if the air is moving with the thing or not moving with this thing. It's completely irrelevant. If you want to say there is no Coriolis because the atmosphere is moving with the thing, that's fine. I mean, that would screw you on a lot of other arguments, but that could be an argument, but that's not your argument. Your argument is there is Coriolis. So knowing how Coriolis works with the inertial and non-inertial frame, it literally does not matter if the air is moving with it, not moving with it. You still have the two different frames with the two different distances, and the inertial one's still the more real one because you can make the non-inertial one. You could get under a merry-go-round right now and spin under a plane.
Yeah, okay. Would you agree that if the air is fixed with the merry-go-round, whatever distance it has to cover over the merry-go-round is the same distance you have to cover through the air? The same length of air you have to go through?
Absolutely not. Pfinky just actually got wrecked on this, and the distances are different in the inertial and the non-inertial frame. If they're the same, you don't have Coriolis effect. Like you guys don't know how this shit works, bro. And you're trying to like debate me on it. Like, are you trying to figure out how this works, or are you trying to debate me on it?
Yeah, I'm trying to. Yeah, be honest and free. Okay,
so imagine me on it, or
imagine the merry-go-round's not spinning; it's still, and the air above is still. Do you then go the same distance through the air as you do over the ground, over the merry-go-round?
There's no non-inertial. You gave me a scenario with no non-inertial frame. There's no Coriolis happening.
No, we're not talking about we're talking about the distance in a straight line when it's not spinning. Yeah, and in that
There's
case,
no
no
Coriolis
Coriolis.
happening.
Would
Are
you
you
go
trying
the
to
same
learn?
distance? Yeah,
Yo,
you
are you
just
trying to
said
learn
that
about
you'd
this, or are
go
you trying to debate
different
me on it?
distance. Yeah,
Hold on, man.
you
Are you trying to learn about this, or are you trying to debate me on it?
Yeah, both. I'm trying to learn and debate because I think my position's right. That's a
You
debate.
can't like fight someone that you can't like try to learn someone and fight someone on at the same time. Like you're like not open to learning if you're trying to debate someone. You know what
Yeah,
I'm
well, I
saying?
mean, you haven't pointed out which part of it I'm misunderstanding that's leading to my wrong answers. So
I've
that's what
pointed
I'm
it
trying
out.
to learn.
I pointed everything out you've said wrong so far.
No, you just keep saying my answers are wrong, but you're not saying the mistake I make in the calculations that's leading me to that wrong answer.
I've pointed it out every time. Why don't you try it again, and I'll point it out again for you.
Okay, so earlier you said it doesn't matter whether the air is moving or not with the spinning merry-go. I argued that's your entire flaw for the Coriolis. That's your only mistake, and
Yeah.
that's why I think you're wrong.
Okay, so you're saying if the air is rotating with the thing, then there is no Coriolis?
No, I'm saying you have to go a longer distance through the air if the air's moving with it.
Okay, so the Coriolis is there if the air is rotating with the thing, like globe Earth scenario, right?
Yeah, I guess you could treat the air as the ground, basically. It's the same medium.
Okay. Okay, and there is Coriolis there. While that's happening, there's still Coriolis, right?
Yes, yeah. In this case, the air would
Okay,
be
now,
pushing on it.
okay, we know how Coriolis works. In the inertial frame, that's the shorter path frame. That's the more real frame. The non-inertial path is not real. I can show you examples of that with merry-go-rounds and all kinds of real-world examples on how the non-inertial frame is not even close to being real. The Newtonian mechanics breaks down like nothing real is happening in the non-inertial frame. Do you understand that?
No, but because the air is locked to the non-inertial frame, that's where the air is moving with. If it's
I know, but do you
rotating with the
understand? You didn't
platform.
answer what I said. Like, see, that's what I'm saying. Are you trying to learn or are you trying to debate me on it?
I disagree. When you said something about physics break, I disagree with that.
Yeah, Newtonian mechanics
Can you
breaks
explain
down in
it?
non-inertial. Yeah, Newtonian mechanics. First of all, I can demonstrate how the non-inertial path is not real because you can change the distances at will depending on how fast you fly and how much you spin the merry-go-round. So those distances just aren't even real at all. And also, when you're in the non-inertial frame, Newtonian mechanics breaks down. They don't work.
Well, you're making a claim it breaks down. What's your
No
evidence for that?
physics. No physics works in the non-inertial frame like physics doesn't work.
Okay, would you agree that a spinning merry-go-round is only part of the non-inertial frame and doesn't exist in the inertial frame?
I don't know.
Or
It's not really. It's
I
not
don't know
really
how to explain
relevant.
it. I mean, as in like.
I don't know what you're saying.
Yeah, I'm trying. I can't put it into words. Oh, like you're saying the non-inertial.
I know
Okay,
you
yeah, I
can't
get
because you
what you
guys don't
mean. Yeah,
understand this. You
yeah.
guys, the reason why you can't put it into words is because you don't understand this stuff.
Okay, yeah, I agree with you. Newtonian physics doesn't work in the non-inertial frame. However, would you agree that only the non-inertial frame is relevant from the reference point of the spinning merry-go-round? Because in
The
that
not real.
non-inertial frame, the merry-go-round is still, right? In reality, it's spinning.
What's the question?
Well, I'm trying to say, like, you can't ignore like the non-inertial frame because your spinning merry-go-round is
You
locked
don't
to
have
that.
to ignore it. You don't have to ignore it. No one said ignore it. I'm just telling you it's not real. The real
Yeah, well,
shit's
you're saying
happening
it's
in the
not real,
inertial
so like,
frame. The real shit's happening in the inertial. Yeah, because it's not real. We're trying to figure out what the shortest path is. And just because it looks like the shorter path is in the non-inertial frame, that's demonstrably not true.
Okay. Again, imagine the merry-go-round's completely still and the air is still. Would you agree that whatever distance you pass over the merry-go-round, over the ground, is the same you have to go through the air?
I don't know, man.
I mean, it's a simple
I don't
question.
know.
I mean, do you think it's different or the same? Like, it's simple, isn't it?
Is the air spinning with the merry-go-round or not? I mean, this ain't about
No,
in the
both are still. The
non-inertial path or the
merry-go-round's
inertial
completely
path.
still, and the air is still, and you go in a straight line. Did you go the same distance over the ground and the air, through the air?
Yeah, 6 meters.
Okay, now imagine the merry-go-round spinning and the air is spinning with it, locked to it. Would you go the same distance through the air as the path you traced over the merry-go-round, the spiral path?
No. Over
Why
the
not?
air, yes, but in the air, yes, but in the inertial and non-inertial frame, no, they're different. That's the thing we're actually talking about is the Coriolis effect. Those paths, like the path you're trying to call, I don't even know what you're doing here. Like what?
Okay,
Well, no,
yes,
he's saying,
okay.
Jeremy, he's saying if in the inertial frame, if you throw a ball on the 6-foot path and there's air above the merry-go-round, the air is going to blow the ball off the 6-foot path.
Okay, so what?
Oh, no, I'm saying you need the
So what?
energy
We're not talking about
to
wind.
go through
We're
the air,
talking about
whatever your
Coriolis
speed.
effect.
Okay, so now, Jeremy, imagine the air is still, but the merry-go-round spinning, and you go a straight line to the edge at 600 miles an hour, right? Would you agree that you would make a spiral path on the merry-go-round, right? If you're throwing the ball in
If
a
the
straight
air
line,
is,
still, yeah.
yeah, if the air is or isn't spinning with the merry-go-round, and the Coriolis effect is present, and you go in a straight line, you're going to spiral regardless if the air is rotating with it or not rotating with it. You're still going to make a spiral, a circle, circles, not a straight line.
Okay, no, I'm asking. So you make the spiral on the merry-go-round, and you threw the ball at 600 miles an hour through the air, which is still not rotating with. Would you agree that the speed you're going over that point of the merry-go-round would be a lot faster than 600 miles an hour because you're covering more distance?
Yeah, it would in the non-inertial frame, it looks like you're going way faster because like I said, I could fly a drone over a merry-go-round in a straight line. The drone could go 6 meters, and that would obviously take a certain amount of time. However, in the non-inertial frame, I could spin the merry-go-round so fast, it would look like it was a 100-kilometer long line. And given that it
Yeah.
was the same amount of time, it would look like it was way faster in the non-inertial frame. However, we know that's not true. We know that actually the fastest path was the inertial frame. That's the real path. The non-inertial
Okay, yeah,
frame
I
is
agree.
where physics breaks down. You can make the distances look like anything you want, depending on how fast you spin the thing or how slow or fast you move the object above it.
Okay, yeah, with the drone, what top speed do you want to pretend to give the drone? It has a maximum top speed through the air.
Can
We
you
pretend
rebut what I
50
just said
miles an
though?
hour?
Can you rebut what just happened though? Instead of bringing up new things nonstop, can you actually acknowledge the things that are being
Yeah,
said?
I fully agree with everything you just said then, if the air is still and not rotating.
Nope. Even if the air is
100% agree.
rotating with the thing, you're still going to have the two different frames.
That's where I disagree.
Well, that's where you don't know.
Okay.
Okay, remember when you were asking what don't we understand? That's it right there. The thing you just said is wrong.
Yes. Okay. Yes. So you believe me taking the atmosphere rotating into account is incorrect, and
I don't have to
I believe
believe
the opposite.
anything about
That's
this.
where we're getting it wrong.
I don't have to believe anything about this. This is all demonstrable physics. Like there's no belief system at play here. This is just how the Coriolis works and your misunderstanding of it. There's no beliefs.
Yeah.
This is all demonstrable.
Yeah. Okay, so for the sake of the argument, we pretend the drone has a maximum speed of 50 miles an hour through the air. That's the top speed it can push itself, yeah?
Can we address? I mean, we're going to just carry on with the thing that you're wrong
Well, no,
about
this is to set up. This is the whole
both
point
of
I
the
want to make,
paths are the same, and
and we can't.
about how
Yes,
you
this
think
will
both of the
explain it.
paths are the same just because the airs rotate. There would be no Coriolis effect.
No,
There's
I'm not
no
making
point in
that
going
claim.
on. There's no point in going on with a Coriolis effect example when you have this inherent thing just completely wrong.
No, but I'm
Like, there's no
asking a
point in
simple
going on with
question.
another example. There's no point in going on with new examples when
You
this
haven't
is just a
allowed me to finish
fundamentally.
it. Then
This is just a fundamentally. No, we did finish the thing that I said you got wrong that you don't think you're wrong on. There's no point in going on to a new example when you can't understand that that's not correct.
yeah, oh, I understand. Yeah, you're claiming that whether the air is rotating or not doesn't matter, and that's where I disagree. That's
You
where
think by
both.
changing the speed from 600 to 50 is going to make a difference in your argument, dude? Like, you don't even understand your own model.
No, I was using it 600 for planes, but that's hard to visualize with drones in a small round. So we'll pretend it's a real drone and pretend it has a top speed of 50 miles an hour. Now, would you agree? So you agreed that, the drone is only traveling 6 meters through the air, but on the merry-go-round, it's tracing a spiral path that could be kilometers long, right? You agree with that? So now imagine the air is rotating with the merry-go-round. Now that drone would have to travel through kilometers through the air to get to that same point. Do you agree with
Doesn't
or
matter.
disagree with
You're
that?
taking a really big leap of faith comparing the Earth to a merry-go-round when the Earth has nothing to do with a
Jeremy
merry-go-round.
brought up the merry-go-round, and I was happy to entertain
Yeah,
that
but you keep on
hypothetical. I'm
thinking
not
that
mentioning.
he's talking about the Earth being a merry-go-round when he doesn't think that the Earth is a merry-go-round. You do.
But he's the one that brought up the merry-go-round as an analogy, and I happily entertain that thought
Yeah, because
experiment.
that's the only place that you can experience Coriolis, not in reality.
Well, merry-go-rounds are in reality.
Yeah, but Coriolis on the Earth isn't, only on a merry-go-round or in a similar situation that's not the actual Earth moving.
Well, I think the point is that it behaves the same way.
It absolutely does not. Show me Coriolis in reality.
Yeah, you can look at gyroscopes have apparent drift, pendulums precess. Exactly. I mean, they don't, not exactly the way they would on a merry-go-round, but applying the exact same principles.
That doesn't mean the Earth is moving.
It's the best explanation of why we see those things happening.
It's your interpretation. It's not the best explanation.
Well, do you have a better explanation that we could test?
Yeah, yeah, yeah. You haven't accounted for all of the variables that are possible.
That's not an explanation.
Do you have a variable that you can manipulate in that experiment with the pendulum?
It's not an experiment. It's just an observation.
Yeah, well, do you have a variable that you can manipulate?
No, like for the Earth-based pendulum, no, I can't stop the Earth from rotating.
If you can't manipulate it, then how can you prove your experiment?
Just make observations, and you come up with the best possible explanation for the observations.
So it's just blah blah. It's no actual science.
No, that's not blah blah. If you want to offer a
It is,
different, better
literally.
explanation, then go for it.
If you want to prove to someone that there's Coriolis on the Earth that would affect the way a plane flies, then show us the evidence for it.
Well, the Coriolis effect for planes is pretty minimal.
So what was that guy talking about? 600 going this way and that way, and 500 like, what's he on about?
You could try listening to him. I could tell you what he's trying to say, but I think if you just listen to him, he might be able to explain it to you.
He's trying to say that if the air is moving with the non-inertial reference frame, which that would just be the non-inertial reference frame. It doesn't like change anything. You just have a non-inertial reference frame and inertial reference frame. And the thing is, Pfinky, we went over it the other day. I think we made pretty clear how nonsense the non-inertial frame is. Physics falls apart. You can make it look like the thing traveled hundreds of kilometers, right?
I mean, you said you thought we showed that it was nonsense. I don't think so. They're just different frames.
Yeah. So if you were to throw a ball, you could throw a ball 6 meters, right? Easy. Can you
Yeah,
throw a ball 100 kilometers? Can you throw a ball 100 kilometers?
I can't. Nope, I can't.
Of course not. So if the non-inertial reference frame says the ball went 100 kilometers, you don't think that's nonsense, or you think you can't throw a ball 100 kilometers?
No, like, well, if you listen to what Scotsman was
Just
saying.
answer my question, please.
No.
Please answer my question.
This isn't. This is
Why?
a
Why
back
won't
and
you
forth
answer it?
conversation. No, you can't throw a ball 100 kilometers.
So the non-inertial frame is nonsense because it says you threw it 100 kilometers.
If somebody was like, I threw the ball 100 kilometers and used the that frame, that would be nonsense. Yes, but what you got to understand is the same is true actually for your argument. For Earth rotation, it's the non-inertial frame is where the plane moves the most, and the reason is because it's carried with the atmosphere.
I don't know. I stopped listening. I was talking to a coworker. What's up?
That's all right. I got to run. We'll talk. We can talk about it later.
I mean, we've exemplified and shown that the non-inertial frame is nonsense. You can't throw a ball 100 kilometers. You could get it. Also, physics completely breaks down in the non-inertial reference frame. Newtonian mechanics doesn't apply. Physics just falls to pieces. You think that's real? Or you think what's real is the frame where physics is happening still? And the
Well,
distances are all accurate.
Well, that's my point. Is you say that like you've constructed a version where you say that's true. What I'm saying is, for in the case of Earth rotation and things being carried by the atmosphere, the opposite is true. Where you would say, "Oh, I flew this plane X amount of distance, but it actually traveled in reality much further." Right? For when we talk about Earth, then your whole argument has to flip on its head because of the atmosphere.
No, it doesn't flip on its head. Like I said, you could have a record player where the air above it is rotating with the record player, and your hand is spinning around with it on the inside circle, very close to the center. And then if you wanted to move your hand in the shortest path, even though the air above the record player and the record player and your hand is all spinning, you would still just push your hand forward in a direct straight line. That's what you would do if you wanted your hand to go the shortest path, even in the scenario wind and the record player, it's all spinning together in lockstep. You would still do the thing I'm saying. You would still have the different paths. The non-inertial one would still be longer. It'd still be longer.
Nope, that's incorrect. I do agree. I was wrong last week when we talked about this. But in the case of I'll be very specific. In the case of something being carried by the atmosphere, the inertial frame is going to be shorter. The non-inertial frame will be longer. I do got to run. I'll post an actual like visualization so you can see the difference.
If your hand's spinning with the inside of a record and you got a marker touching the record, and you want to move your hand in the shortest path possible, even if you're spinning with the inside of the record and the air is rotating with the thing, you're still, if you want to move your hand in the shortest path, you're just moving.
Sorry, I didn't get the last part.
It's still shortest path.
Oh yeah, you cut out on the end. I have a one actually for the Earth that shows the atmosphere moving. You can adjust like how much things get carried, and you can see. We don't have to do record players and hands. We can just do it. You can just see it on the Earth. I'll post it. I'll post it in like 15 minutes.
I mean, if you want to use Earth, you could have a plane at the equator, 2 planes at the equator. One of them doesn't turn left or right. That goes a shorter path than the one that adjusts for the Coriolis effect. It's just facts. It's facts, dude.
What facts?
Where are they aimed?
If you don't adjust, for the Coriolis, that means you're turning left or right less, and you're flying a shorter distance. That is just a demonstrable fact about how the Coriolis effect works, regardless if the air is spinning with the thing or not. It's irrelevant. You have an inert.
Oh, you cut out. Tell me if you're there.
You
I
got a
don't
new
want to
topic?
talk over.
Is there a new topic? Like, because this is getting really like repetitive.
Yeah, I don't think his facts are correct. He's got to look at it again.
No, I don't need to look at it again. If you have a plane at the North Pole and you want to get to the equator, and I don't turn left or right, and I just go fly the plane in a straight line without turning, and you do turn to correct for the Coriolis effect, and you're going from the North Pole to the equator, you will have taken a longer path than me. That's a fact. Turning makes you take a longer path. Does anyone disagree with turning makes you take a longer path?
Unfortunately, if you don't turn and there is a Coriolis effect, you're still going to take a longer path because you'll be turning
Nope.
because of the Coriolis effect.
Nope. You'll
You're
just
turning on the Earth. You're turning because you have like a reference, which is the North Pole, which you have to navigate around on a latitude. That's why you have to turn, because you can't have a direct heading if you're using the compass as your guide.
Okay, Jeremy. So yeah, you're perfect now flying north from the North Pole, trying to get to the equator. Now, the plane that goes with the Coriolis doesn't fight it. Would you agree that by the time you get to the equator, the Earth is spinning sideways underneath you at 1,000 miles an hour? If you never fight the Coriolis.
Can you tell us how we would know that we're experiencing Coriolis when we're on an aeroplane?
I need to know if Jeremy agrees with that flight path.
I just want to know, can you tell me how I know I'm experiencing Coriolis when I'm on an aeroplane? Tell me how
It's
I
so
would measure that.
negligible, you can't feel it physically. It's so negligible.
So if you can't measure it, how do you know it's happening?
Because you can measure it with computers and instruments, just not your
Can
body.
you measure it on an aeroplane while you are flying? Tell me how you do that.
You would have accelerometers. Oh no, you'd have all the flight computers looking at how many adjustments the ailerons kept making, and then you would see they had to make these certain adjustments to keep turning
Yeah, but
and fighting the
you
Coriolis.
ballers always say that you wouldn't be able to know because of the wind, so you wouldn't know which is which.
Yeah, that's true. Yeah, it's negligible. The
So
wind
how
is
do you
far
know there's
higher of a
Coriolis
factor.
and it's not just the wind?
You could simulate how much you would have had to fight. In fact, yeah, I'll concede from the data from the ailerons, you probably wouldn't be able to tell.
I just say you
So
lose and we win.
No, that's like saying you can't weigh an atom on your kitchen scale, therefore you lose an
You're
atom.
pushing shit
It doesn't
uphill
have
with
a weight
like
just
something
because you
that's
can't
not
measure
even
that
measurable.
specifically.
I give up.
You're saying
I mean, you
Coriolis
just
doesn't
conceded
exist
and said
unless
you
I can
didn't
measure
lose.
it this specific way, which we can't. Therefore,
You
it
just
can't
conceded and
exist at
said you
all.
didn't lose. What?
So you're a
All
bit
right.
quiet, Elba.
You just conceded and said you didn't lose.
No, I conceded you can't measure the Coriolis with that method.
Therefore, you can tell whether this is Coriolis or not. You conceded.
You know, jewelry scales, how jewelers have really sensitive scales that can measure like 1 gram, but my cheap
Sure.
kitchen scales at home can't. So would you agree that
Are you
because I
saying
can't
that
measure
they're
it on my
experiencing
kitchen
Coriolis?
scale, therefore it doesn't have weight? Because it says
Are
0
you
on my
are
kitchen
you
scales?
saying that they're experiencing Coriolis?
That's what I'm saying, bro. They're saying there's Coriolis. They just don't get it about the inertial and the non-inertial frames and how physics falls apart in the non-inertial frames. And
That's not
that should tell
true.
you alone. That absolutely is true. Bacon was in here telling us a few days ago how physics. It's demonstrable that Newtonian mechanics breaks down in the non-inertial frame.
But you're not taking all you're talking about is a plane going from the North Pole to the equator, correct?
Do you want an example of how physics breaks down in the non-inertial frame?
No, I'm not. I'm asking a question. What you used for an example, or somebody used for an example of basically a plane going from the North Pole to the equator. That is a latitude distance that, if Coriolis effect is having an effect on the plane is going to drift, travel the same distance as if the plane corrected itself from the drift going south. In other words, no matter which way you do it, whether you correct for Coriolis or don't correct for Coriolis, you're going to travel the same distance.
That's not true, dude. That's not even close. That's not how Coriolis works, my man. See, that's what I'm saying. Yo,
How does
Scotsman
Coriolis
guy? Scotsman guy, you wanted to know every point these guys get it wrong, right? That just now was wrong.
No, I get his point. I agree with him. But he's not
It's wrong,
thinking of the
though.
path.
It's not the same path. They're two different paths. One's
Angelo's
curving,
version.
one's going in a straight line. They're literally two different paths. One guy's going to fly 6,000 miles. The other guy's going to fly 6,000 plus however much he turned.
Okay, so Jeremy, so you agree, fly from the North Pole to the equator, and you go with the Coriolis path, not fight it. Would you agree that by the time you get to the equator, the Earth is rotating under you at 1,000 miles an hour?
Why are we going to move on when you guys got the last part wrong?
See, I noticed you're avoiding that key question because
that's
that
a crucial part.
A lot.
Yeah,
do you agree or not?
If we can get the last point arrowed out, if we can get the last point ironed out, that would reveal a lot, because the last point is completely false that you guys made about them being the same distance.
He means the same efficiency and how much fuel you have to burn through the air. That's what Angelo means, and I get what he meant and agreed with.
No, he said
his
distance,
version.
So they're not the same distance.
No, what Angelo said of not fighting the Coriolis, his version of that path is different to what you think of the Coriolis, that you can fly basically like a rocket through space with the Earth rotating underneath you. So again, simple question: will the Earth be going sideways under you at 1,000 miles an hour by the time you reach the equator on your desired Coriolis path, where you don't fight it? Yes or no?
That's what you guys have the Earth rotating at 1,000 miles an hour at the equator.
Yes.
Yeah. What's the problem?
Okay, yeah, so on the globe model, you would agree on our globe model, if we followed your ideal Coriolis path, the Earth would be rotating under the plane at 1,000 miles an hour, correct?
No, because the air is moving. The air is moving with the ground, so the plane would just be at a point above the Earth in the air. I don't know what you're saying, dude. Say something.
As in order to follow your perfect Coriolis path, it would result in you sticking to a path where the ground's going underneath you at 1,000 miles an hour sideways at the equator. Do you agree with that or not?
I don't know. Are you saying the plane wouldn't be able to land because it wouldn't have the right momentum?
No, nothing to do with the momentum. Let's just say it's 10 minutes before you reach the equator. You're almost there, right? Forget the airport and all that. Would you agree that if you're following that perfect Coriolis path where you're just pretending the ground doesn't exist, you're just following your inertial, not fighting Coriolis, would you agree to go that Coriolis path, the Earth would be rotating under you at almost 1,000 miles an hour at that point?
Would the Earth be rotating under a hot air balloon at that point at 1,000 miles an hour?
That's not my question. Do you agree?
I'm trying to clarify this because I don't understand your question.
Yeah.
I don't understand your question. I'm trying to clarify it. Would the Earth be rotating under a hot air balloon at 1,000 miles an hour? Because the plane could just be at the same spot the hot air balloon is. So.
No, but I'm asked. Okay, so would you agree that your idea is to let the Earth rotate under you instead of going with the Earth? You're just doing nothing and not fighting the Coriolis, which is letting the Earth rotate underneath you as much as it wants to. Do you agree with that? That's what you want to do.
I don't know. I don't know what you're saying.
To follow a plane flying from North Pole to the equator, leading the target, So over the ground, it's a curved path. That's what you want, right? You think it's the most efficient path, correct? You're saying that's better than a great circle route, straight line over the ground to that point in the equator, right?
Yeah. What I'm
Jeremy's
saying is
correct on the distance being slightly longer. It's about tens of miles. We're dealing with 6,215 miles correcting for Coriolis, and about 6,226 miles if you don't correct for it. Very slightly different. But fuel consumption wise, you're going to actually consume less fuel if you correct for it.
okay. Okay. That's my only argument is that the paths are, the path is shorter if you don't correct for the Coriolis effect. So you agree with me? Great. That's good.
But wait, if you don't correct for the Coriolis effect, okay, you're going to have a longer path because Coriolis is going to shift you in one direction off of your, and make an arc trajectory, giving you a longer path than if you correct for it and go in a straight line, because you're dealing with a straight, longitudinal line from the North Pole to the equator, which is 6,215 miles. That's the corrected path. The uncorrected path is slightly longer because of the curve
No,
and the
all you
amount of
would do is
drift.
all you would do is aim ahead of it.
That's not right though. The
But
thing you said,
we're not correcting it.
you're trying to say that the path. You're trying to say the guy that turns versus the guy that doesn't turn. You're saying the guy that turns took a shorter path. That's doesn't make sense in
He's
any
not
scenario.
turning. He's not turning. What he's doing is he's adjusting for the drift. As the plane begins to drift, he's slightly turning the plane in to maintain that straight linear line from the North Pole latitude wise down to the equator. He's not traveling farther. He's not allowing a curve. In other words, he's maintaining a straight line with a slight turn on his plane. That
Yeah,
doesn't
but
make a curved path.
soon as you deviate from the straight line, it's not a straight line.
It's not, you don't understand. There is an
I
effect
don't.
on the plane. There's an effect on the plane that's moving you to the left. You're simply holding the
No,
stick
the
a
plane
little
is
to the
not moving.
right. You're holding the stick a little bit to the right to maintain your straight flight path on a surface that's literally, and you could do this on a flat earth if there was a wind blowing you to the left and you wanted to go from the North Pole to the equator and maintain that straight line, you would have to adjust for that wind, and that would not make your path curved. It still maintains a straight line from point A to point B. The
You don't
distance.
understand.
The distance. What do you mean? I don't understand. I'm the one.
Yeah, because
I'm
the
not having
plane
any
is
trouble
not
understanding what a
deviating.
straight line
The
is.
deviating is it looks like it's an apparent deviation. The plane is flying straight. The problem is that the Earth is underneath you that is moving, right?
It's not flying straight. That's where you're wrong. The minute you
Oh,
start your flight, Coriolis is going to start pushing you to one side or the other. Let's say to the
Coriolis
left.
isn't
And if
pushing
No,
you're
the
me.
adjusting to the
Coriolis.
right,
Jesus Christ!
Hold
You see what
on,
I
hold
mean,
on,
Jeremy?
hold on, Elbow.
These
The
guys do not
Coriolis
know what
doesn't.
Coriolis is.
I know. I sent you that in a DM last night. The Coriolis effect doesn't do anything physically to the plane. The Coriolis force does not push the plane. There is no push on the
no, it's
plane.
the rotate. I know what it's doing, but the point is that it's creating a path that's longer than a straight line. Do you
In the
understand that?
non-inertial frame, it looks like you took a straight line. If you adjust for the Coriolis effect the whole time, if you follow a longitude line, you've adjusted, you've turned your plane a little bit throughout the course of the flight, and you've stayed over a longitude line. That's the shortest path on the ground, but that's the non-inertial frame, and we've went through how the non-inertial frame, all kinds of goofy shit starts happening. You can make the distances be anything you want. Physics breaks, Newtonian mechanics completely falls apart in this frame. So
A great Anglia. Let's take a rocket. So I'm tasking you, planner out. A rocket takes off at the North Pole and its target flies to Ecuador, which is almost on the equator, right? Would you, would you, would the shortest path, as in for the rocket outside the atmosphere, be to go with the Coriolis, let the Earth rotate underneath you? Great Anglia.
Yeah, I'm hearing your question. I'm not understanding quite what you're saying. You want me to
So I'm
take
asking what's the best route for a rocket to go point to point from the North Pole to Ecuador? Is it to fly a straight line, great circle route over the ground, which means it'll be adjusting in space, or just lead the target so by the time it gets to there, Ecuador has rotated into position and is under is
Which
the
one
best
takes a
route
shorter path? Yeah, which one takes a
for
shorter
the
path?
rocket? Anglia. So what do you reckon is the best one?
Which one takes a shorter path?
Bruce, and in regards to the rocket, would you agree the only relevant shorter path is through space? It's irrelevant what pattern it made over the ground, which would be a curve, right?
Well, the problem with the rocket is that you're going to have to go out of the atmosphere, and you're going to account for the amount of, what your altitude is compared to the plane, because you're going to have a longer curved route as you fly the rocket to the equator. But the
Let's pretend
overall,
there's no atmosphere.
well, even with an atmosphere, you still have altitude that you have to gain to get above the plane. Or you want to fly the rocket right at the surface, and
No,
on the
in
same.
space, like a real
Yeah,
rocket.
just use a bullet, dude. Just use a
If I
bullet. That
told
way
you,
you're in the
yeah.
in the atmosphere. Just use a
Well,
bullet,
bullet in the
dude.
atmosphere's got resistance. Is going to, you're going to have to make a pretend bullet that goes, without any fuel, or I mean, it just goes.
No,
But
real bullets, dude. Real bullets. They say they adjust for the Coriolis effect before they make a long distance sniper shot.
yeah,
Yeah, so they're
because
not
what's
shooting
happening
where the
underneath them? What's happening underneath the bullet? There's movement, right? From the reference frame of the bullet, there's movement. From the reference frame of the plane, there's movement. It's adjusting for the reference frame from the plane's reference frame, which is why I say it flies from a straight line from the North Pole to the equator. If it doesn't adjust for, or if it adjusts for the Coriolis effect, it ends up flying in a straight line. But if you're not adjusting for the Coriolis effect, your line is actually going to be curved, or your flight is actually going to be curved ever so slightly against the Coriolis effect itself, because your surface, whatever your target is moving. Where you're going, you're heading, your target is actually moving underneath you. As a result, you have to adjust. If you don't adjust for it, you're going to travel a longer path than if you actually adjust for it. Did I get disconnected?
No, sometimes Jeremy, he loses connection sometimes.
Okay.
I don't know, dude. You guys are
Well, I mean,
you
is it
guys are
right
thinking
though?
something magical.
I mean, think about it from the perspective of the person in the plane and the plane itself. From its reference frame, the Earth underneath is moving. Even if you
Yep,
were on
and you
a
have the Coriolis effect, and we know which path is the shorter path. It's where you go straight in the inertial frame, not straight in the not inertial frame.
no,
That's
from the frame
provable.
of the airplane.
It's
You
absolutely demonstrable. The thing I'm saying is
what's
100%
traveling
demonstrable.
what's traveling the distance? Is it the plane that's traveling the distance, or is it the Earth spinning underneath that's setting the distance? No, it's the plane that's traveling the distance from its point where it leaves to the point where it's the target. And if the target is moving and it adjusts to that moving target, it's going to fly a straight line to that target as a result of it, and therefore travel shorter than if the target is moving and the plane doesn't adjust for it. It's going to end up it's going to curve as it goes into that target.
Yes, you're sitting here telling me that turning, if some guy turns and another guy doesn't turn, you're telling me the guy's path who turns is going to be shorter. That makes no
He's going to
sense in
have to
any
turn at the
scenario.
end of his flight and get back to where the Earth has moved his target.
No, you'd
That's
aim
why he's
different
traveling
at the
longer.
start to lead the target. That's Jeremy's argument.
You're going to miss your target.
No,
If
or
you do
you'd
Jeremy's
adjust it
way,
so
you're going to
by the
miss the
time
target.
you get there, the target meets you. That's Jeremy's leading the target, yeah?
If he's leading the target, then he's not making any turns, but he's also already made an adjustment at the starting point. It's the same distance. And they do actually, they lead the target.
Okay, yeah, with my rocket analogy, forget that. Imagine it's a bullet, there's no atmosphere, and the bullet can isn't falling to the ground. Imagine the bullet can just magically not be subject to ground, but it's going the speed of a bullet from the North Pole to the equator over the surface, no atmosphere at all, right? Would you agree the most efficient path for it to get there, shortest, is for the Earth to rotate under it and it to give into the Coriolis? Yeah. Well, I mean, it has
You
to
guys
if it
are
can't
you
steer.
guys are really you guys are really arguing that the guy that turns is taking a shorter path than the guy that doesn't turn. You know how crazy that sounds?
The only reason I asked you the rocket
That's not true
questions
in
is
it. That's
Angelo.
not true in
I'm
any scenario. Every
is to give
scenario
you the
that's false.
analogy of what Jeremy thinks planes should do. He thinks the shortest path for a plane is the same as the rocket going point to point through space with no atmosphere, and leading the target. So by the time it gets to Ecuador, it's rotated underneath into position.
Yes, that is the
That's
shortest path.
Yes, for a rocket with no
And a
atmosphere,
plane. Why
correct.
would it be
No,
different?
the plane is fighting the atmosphere that's rotating with the Earth.
All right. So a person flying south, if the Earth is rotating, all right, as a result of that, sun's rising in the east, going to the west. If you're flying in a plane because of Coriolis, the Earth's going to be rotating to your left. So you got to basically aim further to the east in order to catch the equator or catch Quito, Ecuador, right at the right time and land on it. But you're still flying a straight line because what you're doing is you're not flying directly south when you leave the, well, you are when you're leaving the North Pole, but you're not flying at the direct latitudinal line at the time when you leave that goes directly to Ecuador. You're going on a different latitudinal line that is going to have Ecuador meet you at the point of where you're landing. That's the correction you make when you fly south and you fly the same distance as if you were to fly on a non-rotating Earth directly to Quito, Ecuador. In other words, not having to compensate for the Coriolis effect. So as a result of the Coriolis effect, you're leading your target.
No, they don't lead the target when they claim that they're making Coriolis corrections, albeit very small throughout the course of their flight. They actually take off pointed at the airport and correct for Coriolis on the course of their flight. Now, if we had two planes at the North Pole and I just go straight south, I go directly. I don't turn left or right. I start going directly south and I just don't turn left or right. That is the path where you don't turn. Not turning is always a shorter path than turning. That is just a fact of reality.
Okay, so for your ideal shortest path of the plane, is the wind a factor? Or sorry, not the wind, is the air a factor that the air will be pushing you a bit and you can't fight it because the plane has a maximum speed it can go through the air, including the maximum it can get hit by without being pushed out. Of course, that's too
I don't
strong
know
to
what
fight.
you just said. I have no idea what you just said.
Because if you didn't fight the Coriolis at all, would you agree that by the time you got to the equator, the Earth is rotating underneath you at 1,000 miles an hour?
Are you saying we wouldn't be able to land the plane?
No.
No, dude, the plane's going at whatever speed the plane goes. The plane always just goes whatever speed the plane goes.
No,
The plane
again,
goes 500
yeah.
miles an hour. When it gets to the equator, guess how fast the plane's going? One guess. It's all you're going to need.
Whatever the top speed of the plane is. Over the ground through the air, that's the speed it's going through the air, whereas it would be different of the Coriolis path through that inertial space would be a different speed because you got like the drone
Okay.
over a spinning record is going a different speed through the still air than it is in the kilometers path traced on the spinning record, right? Two different speeds 2 reference frames.
So, Jeremy, in terms of total distance, they're going to be effectively the same. When you aim ahead, you still fly a geodesic path that goes directly over to the equator and meets Quito when you arrive. When you adjust during the course of the flight, your adjustments are ever so slightly that you end up maintaining a geodesic curved flight directly to the North Pole to the equator and land exactly where Iquitos is going to be. It's the same distance in both. I did the,
What
it's
the hell?
yeah, there's no extra
Yeah, Pfinky
distance
just
from
did this
either
the other
method.
day, and I just demoed him on it. I know. There's definitely a different distance, dude.
Really?
They're
Demonstrate it
100%
mathematically because I'm looking at the math right now and it seems to be working. Here's the post.
If you have we can use a simple example. Can I give you just a simple example of Coriolis without the air rotating with that atmosphere to show you that that's not true, or does it have to be with the air rotating? Hello.
Yeah, with the air rotating. It has to be. Your
Okay,
argument
you have
that if on
that's
our
fine.
globe with rotating air,
Okay,
your
that's fine.
Coriolis path is
You have
better.
a record player. All right, just stop. You have a record player. The air is rotating with a record player. Directly above it in lockstep with the record player. You have a Sharpie marker. The record's white. You have a Sharpie and your hand's connected holding the Sharpie and the Sharpie's touching the thing. You're at the center, the North Pole, basically. You're at the center of the record. If you want to go the shortest path possible for your hand, you will just move your hand in a straight line. That is where you don't correct for the Coriolis. That is the shortest path where you don't turn your hand. That is a fact of reality.
Okay, and how fast would the edge of the record player be spinning underneath my hand? What's its speed? Pretending it's a really fast RPM.
It's not going to be
Quite fast,
spinning at
right?
all. It's going to spin however fast the record player spins. Whoever gets to the edge, the record underneath them is going to be spinning at the same speeds for both of them because they're both at the edge.
Okay, but in that case where the path we traced over the record is kilometers long, that's like very fast, yeah? Thousands of RPM, yeah? For this argument.
I don't know what
analogy.
you're saying.
Remember, you agreed earlier with a
anything
really fast
coherent happen.
merry-go-round. You said like just kilometers. The curved spiral on the merry-go-round is kilometers, but the ball only traveled 6 meters through the air. You remember that argument, yeah?
You guys are still arguing that the guy that turns takes the shorter path. That's incoherent.
No, I'm asking you how fast is the ground or the record spinning underneath you? As I'm just
Do you agree
there's one
path? Do you agree there's one path the guy can go where he doesn't turn left or right, and then there's another path that they go where the guy does turn left or right? Do you understand that? Yes or no? Because I have a
turning
follow-up.
relative to rock.
Yes or no? Because I have a follow-up.
Well, you've refused to answer half my questions, so I'm not enjoying it.
I'm not enjoying
entertain
this
all
either,
your
so.
hypotheticals, even if I think they're red herrings. I entertain and answer them. You refuse to answer my question about a plane traveling northeast, whether it would be going north at 600 miles an hour when you agreed it would be going north at 0 miles an hour if it was going east. You refused to answer that one 3 times.
You don't get any if you're east. If you're going east on the equator, if you're going east on the equator, you don't get any closer to the North Pole. That has nothing to fucking do with anything.
Okay, yeah. So you're going east on the equator, 600 miles an hour.
That's
Do you agree you're going
gibberish,
0
dude.
towards the North Pole? Yes or no?
Yeah, if you're flying east on the equator, you're not getting closer to the North Pole. It's completely fucking irrelevant, dude.
Okay, now imagine you're flying northeast at 600 miles an hour. Are you getting closer to the North Pole at the equivalent of 600
if you're
miles
going
an hour?
north, you're getting closer to the North Pole, yes.
Okay, would me going northeast be getting closer to the North Pole at the same rate as a plane flying directly at the North Pole?
Nope, they'd be getting closer at different rates, obviously.
Okay, so the one flying directly at it, which would be like a great circle path, is getting to the North Pole faster than the one going northeast.
Yeah, if there's no Coriolis at play, then yes. When Coriolis is at play, that changes everything because now we have two different paths: the non-inertial path and the inertial path.
Okay, now let's flip it. They're flying from the North Pole to the south. You've got a plane flying great circles south at 600 miles an hour. Would you agree that the one following the Coriolis isn't going perfectly south? It's going like slightly southeast, a little bit, whatever, yeah? Leading the target. Would you agree?
One would be flying in a different direction. One would be going directly south. Another one would be flying in a different direction. Yep.
Okay, so would you agree both that, so the one that's, okay, so would you agree that the one going southeast a little bit is not approaching the south target at 600 miles an hour? Like you agree the one going northeast is getting north slower than the one.
Well, this is different. This is different now because now there's Coriolis. The one flying south, the one flying not directly south the whole time is actually taking longer to get because that the non-inertial frame is irrelevant because now the Coriolis effect is at play.
But
Jeremy,
so,
I put the whole math, the entire mathematics behind these two geodesic circle routes that we're doing, because both of them are a geodesic circle route, whether you are aiming ahead for the target or adjusting as you go along. Both planes fly the exact same distance. There's the math for it.
Yeah, it's literally not even close to being true. If
It's
you had
math.
a
I'm
plane,
sorry. When math
hold on a
comes,
second,
when you have
man.
math that proves
Hold on,
something,
let me
it's a
explain it.
proof.
I'm going to explain it. I'm going to explain it, dude. One guy is flying a path where he doesn't turn left or right. He's going A to B, 6,000 miles to the equator. The other guy is turning left or right. He's going to have a curved path. He's going to be flying a longer distance. A curved path is a longer distance than a straight path. That
How
is
is he
a
flying a
fact.
curved path? How is he flying a curved path when he is flying over the surface of the Earth, which is where you're measuring your distance? You're not measuring your distance by his little adjustment in the plane. You're measuring it from if you drew had a pole going all the way down to the surface and had it drawing a line on the Earth. Okay, while he was flying, with his little bits of adjustments, which are ever so slight, you're going to have a straight line. He is maintaining a straight line. He's not allowing the
In
line.
the non-inertial, great, Angelo.
No,
In
this is the inertial frame point.
non-inertial,
This is the frame. The point of frame is the airplane, not the inertial frame point from the surface looking up at the plane. You are taking it from the plane and putting that point down on the surface of the Earth and drawing a line with that point. It's almost like you are flying a pencil, basically, with a pencil sticking down. And that line is going to be a straight line on that sphere, a geodesic line that goes from the North Pole to your target, which is because you're making an adjustment. You're making an adjustment to your target line. It's going to be the same straight line. Well, why did you read my math at all? Did you bother to read the math at all? Jeremy, did you read the math? Yes or no?
I don't need the math for this. This is just physics. This is path.
No, it's not
distances.
physics.
Just let me finish, dude.
It's geometry.
Come on, man. All right, guys, settle down. If one guy turns and one guy doesn't turn, they took a different path. One of them took a straight line. The other guy turned and took a curved line. You're saying a curved line and a straight line are the same distance. That's not true. I don't need math to show me that that's not true.
It's getting
That's just
adjustment,
blatantly
mate.
not true. Like there's no math that can show me a curved line and a straight line are the same distance.
Listen, the person in the air,
You sound like you're
airplane
gonna be
is
a
making
peach
adjustments. Do you understand?
Listen,
the Coriolis is very, very small.
Listen,
Jeremy,
if
you're
you
not
take
gonna
a
let
curved
you're,
path
you're not
and a
gonna
straight
let
line
him
path,
speak.
it's gonna be different distances. Listen.
Jeremy, you're not gonna let him speak, Jeremy? Come on.
The Coriolis is a very,
came in
very
yelling
small,
at me like talking about listen.
It's easily overcome by all sorts of other forces like wind and so on. The autopilot in the plane will automatically adjust for any of those forces, like Coriolis, like wind, all sorts of things. Coriolis is a tiny force. It's not going to veer off in some direction that you think it's going to make a huge difference.
Sounds like your problem.
I never said it was going to make a huge difference. That's just a straw man. I never said it was going to make a huge difference.
I said it was going to.
Who's not letting who finish now, B-ball? B-ball, who's not letting who finish now?
Well, I mean, you talked over him, then someone else jumped in, talked over
All
him.
right,
So
come
I
on,
don't know.
guys.
If you
So
think
I
the
never
Earth is
said it was
flat,
going to be a huge distance. I never said it was going to be a huge
then what's the
distance.
problem then?
That's a straw man. He's still not letting me talk, B-ball. What do I do, B-ball?
Then
Go
go
on,
on
talk.
mute.
What should I do, B-ball?
You should go on
Talk.
mute and then let him know. Tell
And
him when
not
he's done.
and just so
Say you're
he can
finished.
just not let me finish ever. All right, that
No,
sounds fair.
because I've been hearing you the entire time. So tell him. So hey, when you're done, say you're finished. Okay.
Yep, go ahead.
He's been done, dude. He's just fucking interrupting me. Like you yelled at me for interrupting him one time.
Go ahead,
I'm
Jeremy.
waiting
Just
for
go on.
you. Talk.
So that was a straw man. I never said it was going to be a huge difference. I said there will be a difference, obviously, because if one guy turns and one guy doesn't turn, those are going to be two different paths and they will have a different distance.
All right, can I talk now? Okay, all right. There won't be any difference, and I'll tell you why there won't be a difference. Because the autopilot in the plane will automatically try to keep its own bearing. By doing that, it will correct for wind, for Coriolis, for all the forces that are involved in stopping that plane from heading for its own bearing. There will be no difference at all. Nobody will notice that there was Coriolis. The reason is because it's tiny, and the autopilot in the plane will take care of that. Forces like wind and currents, way bigger than any Coriolis could ever be, and the plane is fighting those currents. You think it's going to take any account? It's going to matter what the Coriolis is? If you want to believe in flat Earth, that's fine. Make up your own flat Earth physics, but don't make up globe physics, okay?
All right, Jeremy.
Are you
He's
done?
right in
Hold
one
on.
sense.
So what he just did was
He says
negated his whole point.
basically what we're trying to tell you is
I
there's
know.
two types
He
of
didn't address
distances that you're
anything I
talking
said.
about.
Now I can't respond to that. Like, I don't.
I've been waiting quietly. You responded to him once and he responded back. I'd kind of like to jump in with this. Okay. The geometry of a sphere differs from in intuition from the geometry on a flat surface. On a sphere, a geodesic is inherently a curved in three-dimensional space. If you make adjustments to stay on it, those ever slight adjustments don't make your path any longer. And they're happening constantly. It's almost like you're constantly staying on that geodesic. And you end up in Iquitos, no matter, or in Quito, Ecuador, no matter what. It's no matter whether you adjust for it ahead of time by aiming for it, to the left and aiming for it, hoping it's going, knowing it's going to arrive there when you arrive, or if you take a geodesic path that's constantly adjusting along the way, mathematically it comes out to the same geodesic path with no distance added, none whatsoever. It's basic trigonometry. You can't make the statement that you're flying longer. I know intuitively you think because he's curving, he must be traveling farther, but he's curving on a geodesic and three-dimensional space, not on a 2D flat surface. Yes, on a flat surface, he would be traveling farther, but we're not traveling on a flat surface. We're traveling on a curve.
That's
Yeah, I
the claim.
realize you have to. I realize
It's
you have
not
to
that
curve.
hard.
Oh God. All right. Let me know when I
Go
can
ahead,
respond.
Jeremy. Yeah. Prof, just hold on a second.
So I realize you're in this idea. You're curving over a ball, and if you're curving over a ball and turning left or right, that's a longer distance than curving over a ball and not turning left or right. That's why they say a great circle route is the shortest path, because guess what happens in a great circle route? You don't turn left or right. Everyone knows not turning left or right is always a shorter path.
What type of a route did he take when he left from the North Pole and ended up in Quito, what with those adjustments along the way? Show me anywhere
Can you
along
adjust?
that route. Hold on. Show me
Can you
anywhere
address what I
using
just said,
trig.
though?
Yeah, I am
Can you address
addressing it.
what I just said?
Spherical geometry. Okay. You're saying he's making these little curves along the way. Okay. All he is doing, he's not curving the plane. He's just keeping his nose on a heading on that one spherical great circle route as he goes along. While the Earth moves under him, he is slightly adjusting his curve to stay on that spherical curve, great circle route. When you do the math and you figure that out, those slight adjustments keep him on the same path, which is a great circle route. He ends up flying the same distance as if he aimed ahead, flew on a great circle route that was on a different line, but landed in the same place because the Earth moved out from underneath him. You understand that you're not moving just on a sphere, trying to stay on a circle route on a sphere, but you're moving on a circle route that is moving with the Earth, trying to maintain the movement with the Earth. He doesn't fly any longer. He doesn't fly any farther at all. They're both the very same distance down to the millimeter.
Let me
3D
get an answer,
geometry will
Jeremy.
show it to you. The minute you put movement on the Earth itself, you've got to basically two possible ways to get to your distance. One, aim ahead, and the other one is to adjust along the way, and they both are the same distance because they're both
That's
great
what you're
circle
claiming.
routes.
That's literally impossible. That is physically impossible. A guy that turns and a guy that doesn't turn, they have different paths. One of them's a straight line. One of them's not a straight line.
When you draw the two lines,
it's physically impossible for them to be the same path. When you're dealing with the Coriolis effect, like I don't think you understand how this works.
I understand it perfectly. What happens is the minute that those two planes take off, let's say they take off we have two dimensions, two dimensions. One Earth, the plane's taken off anticipating. The second Earth, the plane's taken off adjusting along the way. When you draw the lines for both of those paths, they're going to overlap when you merge the two Earths together. They're going to be the very same path. Because as he takes off, the one aiming ahead already is going to the left a little bit. But so is the guy who's taking off adjusting for the great circle route. He's basically doing the same thing. The two routes, the two paths are going to show up on top of each other. He's not going to be making a big long arc. He's going to be flying the identical same path as the person who flew straight aiming ahead.
Now, they're literally different paths in the inertial frame, and they're different paths in the non-inertial frame. In the non-inertial frame, you can make the distance be anything. What you can't make it do is be the same, though, as the guy who doesn't turn, because those are literally different paths in either frame. The non-inertial frame has one longer than the other. However, they are different distances, different paths. That's just a fact. I don't know. There's
The
nothing
best way I could describe it is if you had those two planes, if you could see both of those two planes at the same time when they took off, one's nose would be pointing in a different direction, but the path he's taking was going in the same direction as the one who flew in a straight line. That's the difference. You just don't, you would look at that nose and see it ever so slightly to one side or the other, but the plane is still following that arc with those minor adjustments. And those minor adjustments don't add to the distance because he's staying on the same the same geodesic flight path.
Angelo, you do realize that no matter how many times you explain it to him, he just wants to be correct. He wants to be right. So there's no point.
Well, anyway, Jeremy, I left it in chat, the math that's involved with it and why it's correct. It's
Can somebody explain to me? Can somebody just cut to the chase and tell me, what's the issue? How does that prove that the Earth is flat or not flat?
Doesn't.
It's your issue that you don't know what Coriolis is. You guys say you have a map, you have a difference, but you don't. You don't have difference, and you can't show it in real reality. You're on a flat, like AE map. You don't have a flat, straight line going from point A to point B and any curved line matching that same thing. You don't have that. Why are you asking Jeremy to draw your guys' proof? Your proof is that the straight line and a curved line, like a straight sidewalk to grandma's house and a curved sidewalk, is going to get there at the same time. So you guys need to demonstrate that. Jeremy wouldn't have to demonstrate your stupid claim that doesn't exist in physical reality. Point out the physical difference of your claim, Coriolis versus every other effect in real-time reality. Show what it does to the object instead of anything else. And then put it in play. You're full of it.
Which part of the aeroplane takes account of the Coriolis as it's traveling. All the aeroplane does is head for its bearing. It's got a bearing. You dial in the bearing on the autopilot, and it heads for that bearing, and it makes all the corrections it needs to do to stay on that bearing. Do you understand that?
You got a toy airplane and a ball to show us how that works?
You don't
I know
have to
you know
touch
what a
the
straight
airplane.
path and a curved bearing is.
The
Hold on, bro.
airplane will
I
make.
wasn't done talking. I wasn't done.
Stop.
Do you have a ball and the airplane and show us with your hand, grab the airplane and drive it around how you just claimed? Show Jeremy both different paths.
The aeroplane will just simply head on its bearing. It will make the necessary adjustments so that it stays on that bearing. Do you know what a bearing is?
Yeah, I wish you'd show me with the little toy airplane around your fake ball.
You don't know
Why
what
is
a
this so
bearing
hard
is.
for you to do? Dude, stop
We
imagining
can't
stuff
have
and
this.
asking dumb questions that you need to demonstrate.
If
That's
you
your
don't
problem
know,
that you don't know what the bearing is. You're not
if you
demonstrating,
don't
are you?
know what a bearing is, we
Show
can't have
me.
this conversation.
Show me how you know what it
Oh, you're
is.
talking to what's his name?
Democ.
Yeah, we don't need a reiteration
Democ,
on my name,
dumbass, as I like
Goofy.
to call him.
You need a ball and a plane. He doesn't need
He's
to
never going
know.
to let you talk or
I
say a
think
word
he
in
knows
edgewise. He'll
he's
just
talking.
talk all over you
Green
no matter
lights
what.
on. You
And
need to
he's
tell this
worse
guy
than
how to
you are.
I
read,
got you,
dude.
Demok. I got you. Don't
So
worry.
you need to tell this guy how to read
Yep,
my
I
name.
got you.
Are you serious?
Hey,
Is that what we're
yep,
doing here?
I
So
got
we
the
don't
perfect
have
picture for
anybody
you.
with a ball and a plane showing their story, their religious claim.
I got the perfect pictures for you. Just
I
give me a
posted a
second.
graphic if you guys want to take a look at it.
No, nobody cares about that.
A graphic's not going to help. They have to show you exactly what they're talking about with an airplane and a ball, or else how the hell would you know what they're making up in their mind?
Mm-hmm.
Doesn't make any sense. Couldn't be
Yeah, and
done.
Democ, it's not our fault that you can't do a thought experiment, that you don't have the brains for a thought
Not my
experiment.
fault. You
You
can't
also
follow
don't
through
have
with it
the
like
brains
a
for the
2-year-old.
trigonometry that I just
Hey, you don't
described.
know how to get a toy
Basic
airplane. Don't
mathematics.
talk about
You can
trigonometry.
talk to me all you want, but I'm just going to say what I need to say, which is basically if you don't understand the math and you don't want people to
Math to
present
what?
either a
You're not doing
diagram
that. Math to
or
what?
anything else, that's
Here
not
you
an
go,
us
Demok.
problem.
The
That's a
math of
you
nothing
problem.
around nothing. Gonna
Here
help
you go,
no one,
Demok.
buddy.
Just
Yeah,
for you.
math of no airplane not doing nothing that you haven't
Here
shown. That's the
you go,
dumbest
Demok.
thing to say, math guy.
Here you go,
Numbers in
Demok.
the air in your mind are going to say numbers in the air in your mind. And now in your mind, you're going to number something to death. You guys are stupid. Get the ball out and show what
There
the
it is.
math is telling you.
I
If
just
you can't
posted
do
it just
that,
for
then you
you.
don't have any math.
I just
Liar.
posted it just for you. There you
Democ,
go.
there's a
Yeah,
nice
I'll
little
wait
video
for
for
you
you.
and the ball, stupid.
Yeah,
I
yeah,
know it's not you with an
that's
airplane and a ball.
what Demok was that's what convinced you. This probably this video right here.
A real ball will with a toy airplane. I know it's
This,
above your
yep.
guys' pay
This is
grade, the
what convinced you
military and
that the
all.
Earth was
I
flat.
know, dude, stop talking over me. I know you fucking hate to
No, you talk
demonstrate
over
anything.
everybody, so who gives a fuck?
Yeah, you
Nobody
guys
cares.
want to say
That's
numbers,
why
say
you're muted
stupid
in
shit.
every. That's why you're
But the
muted in every
guy
show
that
because
says
no
the
one gives a
numbers
fuck
and who
about what
talks
you say.
over me in the
He's
military
banned in our
can't
server.
touch an airplane. It's above his pay grade to touch an airplane and a ball and show us what he's talking about. The guy in
Yep,
the
I showed
Well, I'll
you.
tell
military
you what, I'm
said he's got
flying.
numbers for what a plane does, but not the plane and
Hey,
not the
Democ,
ball.
I'm flying to Spain this summer to go see the eclipse. Do you want me to go ahead
Show
and see
me
what's
how with a
Not a
plane and a
rebuttal,
circle
ball.
around
dude.
going to be going?
Show
It's
me
Not
how
a
you're going
nonstop.
rebuttal.
on a ball with a toy
It's
airplane. Liar.
Not a rebuttal, great Angelo. Not a rebuttal.
it's
Yo,
all right.
these
It's
guys are
anecdotal.
arguing. These guys are arguing that if a guy goes to one point and doesn't turn, and a guy goes to another point and does turn, they're arguing that two different things. They're arguing that they're the same distance. That's not true in either of the frames. Also, the one that's shorter is the guy who doesn't turn. That's why a great circle
So,
route on a globe.
Jeremy,
That's why a great circle route on a globe is the shortest path on a sphere, because the guy who doesn't turn takes the shortest path.
but Jeremy,
It's
that plane
literally
is
built.
on the
It's
great
built
circle
into
route.
your own model. It's built into your own model.
Right. You're right.
Hey,
How old are you,
Listen to me for a
Michael? Do you
second,
not know how to
Jeremy.
not interrupt people, dude? How old are you, Michael?
You just interrupted everybody.
Yeah, so
Just say that.
Jeremy could finish his
Just say
point. I
that.
didn't hear the end of Jeremy's
You
point.
just
So,
interrupted. Just
Jeremy, if
say
you
that.
could repeat the end of your point,
Are
that
you
would be
listening to
great.
me? The mod in here, right? That man just doxed me. Do you understand?
I didn't hear
Dude,
what
your
he's.
name
I
is
didn't
the
even.
great Angelo. I'm just assuming your name is Michael, dude.
He's done this before. I've already complained to Gio. If he doesn't get a ban or some kind of punishment right now, I will do retribution on the server immediately. I'm not going to
tell anyone my name is
Somebody for
Besky, I'm
guessing
gonna
the
be
Ninja
so
Turtle
mad.
name?
I've
Yeah.
never
Dude, your
told
name is Great Angelo. Do you know who the Great Angelo is? It's Michelangelo. That's who the Great Angelo is. So
I've warned
therefore,
him
if
for
I call
I've
you
asked him for
Michael to tell you
you're
to
not going to do
shut
anything
up,
about
that's
it.
not me
That's it.
doxing you.
No, I'm
Doxing
done
would
with
come
this.
with
Gio, I hope
threat,
you're listening because you're about to get your fucking server taken down.
Oh yeah, that's fun. Yeah,
I
who wants
didn't
to
So
dox
now
Hey,
you're
anyone.
can I make a
threatening?
Doxing
comment?
would come with a threat,
Station,
Great
he's
Because he
still
said the
Angelo.
Ninja
Hey,
Turtle
I'm
name.
waiting to make a comment
him
about the
punished
airplanes
for it.
thing. Yes, let me make a comment
Don't
about the
say
airplane.
Ninja Turtle, Michelangelo.
Yeah.
You might get
Yep,
doxxed.
let me say
Michelangelo,
something,
you know
please.
what else? Just leave our
I guess
channel
Angelo's still
because you
freaking out.
interrupt
Oh,
and
now since you
incessantly
know
and
that, hold
insult
on.
people. Those are all breaking the rules of this channel. So I don't know
Yeah,
why you would think we would give a crap about
Hey,
you,
Torah, how's my mic?
Michelangelo.
hold
Torah,
on
how's
one
my
second. Can
mic?
I say something? Can I say something? So now that you know that that's his name, you're gonna keep saying it. It's kind of
Keep
You
fucked
guys
up.
need to
trying.
get back on
That's
subject.
right. It's fucked up. He's done this twice now. He did it
Try,
to me
No, I
baby.
have not.
and he's doing it again.
Okay. Dude, the great Angelo is
If you
Michelangelo.
look at
Everyone
the
knows
messages
who the greatest
and the
Angelo
response that he
is,
made,
dude.
you can look
Okay.
at it, Earth
Yeah,
for Life,
enough
and then
about
you can
this
see
name
he's
thing.
done
Can
this
I please
before.
speak on the
Yeah.
airplane topic, please? Yeah, like what truly is the difference on like during your flight? How do you know that you're flying in relation to a curve versus in relation to a horizontal plane? What's the real difference?
In physical reality, boys.
The
Like,
distance.
show us. On the
The,
ground, on the
the
wall. What's the
distance.
difference?
Yeah, but what about from the reference frame when you're actually referencing the ground?
I don't know why y'all are arguing about
You're saying that
Coriolis.
the difference
What's the point?
is reflecting an arc length when it really isn't because your flight is reflecting a horizontal plane. So
Yeah.
to just call
Well,
that horizontal distance an arc length, where are you getting the arc from?
the distance is what kills it. So we can
So the
argue about
distance is
Coriolis
telling
all
you
you
you're
want.
arcing? How?
No, just the distances between places on the surface of the Earth, man. There's no point arguing about Coriolis.
Yeah, but how do you know it's an arc length?
We just
Show us
know the
where there's the
distance.
curve
We don't
between
have to
point
worry
A and
about the
B,
argument.
dude. When do
Okay,
you
so
draw a curve between point A and B? B-ball the fastest way.
And even Jeremy agrees with if the distances are correct, then the Earth can't be flat.
No, he didn't. I don't think he would ever say
Yeah, he
anything
did.
that you're saying
Yeah,
would make any
yes, he
sense
did.
because
Ask
you're
him.
just, dude, can you shut the fuck up? How'd
No,
you get
can
in the
you shut the fuck
military,
up?
boy?
Can you shut the fuck up? Because nobody's
No,
talking to you.
motherfucker, I'm your captain, little private
Nobody's
bitch.
talking.
You
Nobody's
shut the
talking to you.
fuck up.
You shut the fuck up.
Respect your
Go drink
elders,
another
punk
fucking
ass
beer.
motherfucker.
Go drink a fucking beer. Shut the fuck
Shut
up.
the
And nobody
fuck up,
cares.
you little
That's
faggot.
why you're fucking muted in every fucking server because nobody
Because
gives a fuck
bitches
about
like
what
you
you
can't
say.
handle the truth, you little
Every server I
military
go to,
lying
you're
ass
fucking
bitch.
server muted. I
Your
wonder
job is
why.
to
I
lie,
wonder
you
why you're
pussy
fucking
ass
server
fuck.
muted in every fucking
Yeah,
server.
because you want people to yell
Isn't
at
that a
you.
coincidence? Isn't that a coincidence? Thank you.
thank you for what, dude? You're just pretending it's an arc length.
For server
You're saying,
muting,
look, the distance is an arc length, but how do you know that?
because we know the distance that airplanes travel. That's why.
That's just absolute baloney. Like you don't know that it's an
Are
arc
you
length.
sure
You
about
see
that?
what's happening?
Are you sure about that?
Well, how did
So
you
if an air,
find out that it's an arc length?
so let me ask you a question. So if an airplane travels 7,000 miles and it took it 14 hours, how fast was it going? Can you figure that out?
You would only be able to give you an average speed from that.
Sure. Why not?
Yeah, that would be an average speed. Do you agree that
Sure.
that airplane was
Yep.
traveling at 1 mile an hour at
Yeah,
one
that
point?
relative speed is relative to a surface that you're treating
It's an
as a
average.
planar surface.
Sure.
So do you
Okay,
agree
Sure.
that that
a planar
airplane
surface.
was
Good job.
traveling at 1 mile an hour at one point?
No. Well, yeah, at one
No,
point, sure.
never? Okay,
Sure.
yeah,
At one
thanks.
point.
Okay, so then it traveled at 1 mile an hour at one point.
Yeah,
Is
but
that
we
good
know the
enough for you?
distance. But we can figure out the distances between airports using that average, regardless
Yeah,
if
but
it
what if
took.
it's
No,
just laterally?
those distances that you derive between the airports are all based off of a ratio called 60-1.
Okay. So if it took me, so let's say I drive to Walmart from my house, right? And I drive 5 miles an hour. I drive 20 miles an hour, 15 miles an hour, but it takes me a specific amount of time. Do you not think I can still get the
Yeah,
accurate
what's the
distance?
difference
You would just
between,
get your
Hold on,
average
hold on,
what's the
speed,
hold
difference
on.
dude.
between the linear distance on the globe and the
Hold
arc length?
on. Could I get the
No,
average?
not hold on. This is what matters. You just asked a very valid
Okay.
question, and this is the reason that your globe is wrong. What
It's
is the
not. Okay.
distance, that 10-minute travel to get to Walmart? What is the difference between the arc distance and the regular chord distance? It's literally
Not very.
nothing on your globe.
Not very
Nothing.
much.
It's
Sure.
no,
Not
it's
very much.
nothing. Not nothing. It's not very much. It's nothing.
It's
Yeah, but
nothing
we
over
know.
3,000 miles, dude.
But remember that y'all don't have a map to go with, so we have to go with the
Yeah, we
distances
do.
given
We have
by.
a map.
Hold on,
We
I
just
wasn't
take
finished
the
what I was
globe.
saying.
We'll
I
just use
wasn't
the
finished what I
globe
was saying.
map.
So we have to go with the distances given by Google Earth, right? Because you guys
Sure,
don't
there's
have
the
a map.
map. There's the globe map. Yeah, we'll just take
Mm-hmm.
the globe map and say that is a map, and we can map
Mm-hmm.
out our world, and it doesn't necessarily represent the terrain.
Okay, well, you can make that claim, but it wouldn't be
Yeah,
I've
and
got
you
a
right.
can't
professional
defeat it, and
globe.
you have no rebuttal to
No,
the claim either.
because we know the
I've got a
distances between
professional
airports,
globe, and I guarantee it's a very, very accurate map.
right? And we
Yeah,
know the
sure.
distances between.
Accurate to what?
We know the distances
Accurate to
between,
60 to 1. Yeah, that's how we
and,
got all the measurements. It's all
and we
based off
know.
of a ratio. Do you know what an inch is? It's based off 60 to 1. Do you know what a foot is? It's based off 60 to 1. A mile based off 60 to 1. All of it is based off 60 to 1, bro.
Right, and we know the distances between airports in the southern hemisphere, right? Do you agree?
Because we based them all off 60 to 1.
So, do you think are you trying to claim that they're not correct?
Not at all. They're
Okay,
all based off. If you wanted to base them off 58 to 1, you could have done that too. Or if you want to base it off
all right,
10 to
no.
1, you could have did it off that too if you wanted to.
So, if it takes an aircraft 14 hours going 500 miles an hour, 550 miles an hour, you don't think we can figure out the distance?
Aircrafts don't do 550 mile an hour the whole
What's
flight,
the
dude.
average? What's the average price? What's the average? I can use the average.
Go ahead, get the average, dude.
550 miles an hour.
Yeah, it started at 1 mile an hour. Don't forget to include that one.
But the distance is always going to be within a certain amount. It's not going to
Yeah,
be
it's all
thousands
based
of
off
miles off.
60 to 1, dude. What does
It's not
that
going to
matter?
be.
All of your miles are based off 60 to 1,
What,
dude. Do you not
what does that mean?
understand that concept?
What
Yeah, you
What
don't
does
get
that
it. You
mean?
don't even know
What
what
is?
that means.
No,
You
I
don't
don't.
even
I
know
don't know
how
what
we
that means.
derived a
I
mile,
don't.
bro. You
I
don't
don't
know
know what
how
that
we
means.
derived a mile. Do you think someone paced out a mile on the ground? Do you think that's how
Yes,
we got it?
Yeah,
yes. A Roman
Okay,
soldier would
using
walk.
what? Using
A
what?
Roman soldier,
I
a
don't have
Roman
to. All I
soldier.
gotta do is. All I gotta do is use speed, time, and distance.
Okay,
Where the
Roman
stat
soldier one. For this, I've rebutted the Roman soldier so many times in here. A Roman soldier
Let's go
mile is
through it.
not 5,280 feet.
where the
So let's.
statue from is 1,000 paces at the different. The average a foot length between each pace is 5.28 feet. That's where it comes
Yep.
from. It's 1,000
Incorrect,
paces.
sir. Nobody
That's
steps
where it comes from.
I don't even think
5.28 feet.
understand
Nobody in the
why you're
world is
saying.
stepping 5.28 feet. You're retarded.
That's the
I
that's
understand.
what that's what the span of 1,000 paces work out to be.
That's not what we got, Art. That's not how we derived a mile. Maybe back in the day, yeah, that's what they did. We don't do that today. We use something that is more secure. We do 60 to 1 because a star changes in angle after you travel 60 nautical miles. It changes by 1 degree. We derive all distances based on that. Nobody has ever checked with their
Yeah,
paces to
Really?
see if a
nautical
mile is 5,280 feet. And the bottom line is you couldn't because what you're going to
Well,
need is a ruler that's based
line,
off of 60 to 1. And if you're claiming there is an
the
ultimate
nautical
standard ruler in some museum somewhere, you're going to have to present evidence of that ultimate standard ruler because you don't have it.
a nautical
so we
mile is 6,074 feet. A mile is 5,280 feet. So a statute mile and a nautical mile aren't the same units.
It
so you
doesn't
don't
matter,
think that
dude.
we can
It's
use.
a ratio that we derive them from. We derive the statute
The
mile
60,
off of the nautical mile. The nautical mile is just a ratio from the statute. You could just times it by like I can't remember what it is, but it's like 1.015
it
or
just
something like that.
it all comes to 360 degree circle, guy.
That's arbitrary. There's no absolute reason that a circle should be cut into 360 parts.
So you don't think we can use speed, time, and distance to find out any of those variables?
It doesn't matter. You would just be
Why doesn't it?
reaffirming 60 to 1.
Why doesn't it matter? Why doesn't it matter?
All distances are based off 60 to 1. So when you tell me a mile is this distance, that's because you looked at the sky, took an angle measurement to the star, and divided it into 69 equal
You're
parts.
not even on the same page as me. You're just, I don't know where you're at.
You don't even know how
I
we
don't even know why
derived a
you think
mile.
why do you think that's even valid? Like, why are you trying to use that as like, oh, you can't? Oh, now we don't know the distance between airports. Apparently,
That's not what I said. We do know the distances
we
based off
do.
of 60
Exactly.
to 1.
Exactly. And how does that debunk? How is that not comporting to the globe then?
It comports to a globe. That
I
doesn't make
agree.
it necessary that the Earth is a globe.
Okay, so
That's
what
a
does it make
non
it then?
sequitur. To say
What
that
does it
we
make it then?
derived the map off of taking angle measurements to the sky, therefore the Earth is a
No, it's
globe,
not. We're
is
not.
non
It
sequitur.
has
The
nothing to do with
conclusion
angle
does
measurements.
not follow from the premises.
It doesn't.
What about the
We're
fact
not
that they?
taking angle
What,
measurements from the sky. We're just taking
Can
off
I
from
say
one place.
something?
Hold on. We're just taking off from one place. We're landing in another place. It takes a specific amount of time, going a specific speed, and it gives us a distance.
All of that is derived off 60 to 1. Where do you think you got miles per
So
hour
what?
from? You
So
got it
what?
from miles, and then your
And
timing is derived off the sun. So
and
all of it is already in the model. Dude, it's all
and
in the model. You got all of your measurements from 60 to 1, dude.
and that means what? That means they're
That
not
means
correct somehow.
if you want to label distances upon the earth, you can take angle measurements to stars and then declare arbitrary distances.
No,
Those
we're not using
distances
the
are
stars.
accurate to us, but they don't tell us anything about a shape, dude.
We're not using
Yes,
the
they
stars.
do. Can
The
I say
Yeah,
something?
distances can't tell you anything
you-
about the shape specifically
Can
yeah,
I
they
because
help
can.
what
him?
you're
Yeah, they
doing is
can. They
measuring
absolutely can.
differences.
You want to know how?
You're measuring point A and point B off of a celestial sphere.
You want to know
Let
how
me
they can
help
do?
him.
They can comport because I can take a flight in the northern hemisphere, right, and I can take a flight in the southern hemisphere, and both of them will be the same exact distance.
That doesn't
Earth is like,
determine the Earth is a globe.
It does. It
can you
does.
let
That
That's
means
can
they're
you
non
let
both
Professor
sequitur.
symmetrical.
Phil? Can you let
That
Professor
means
Phil though ask a question?
100% proves the Earth's a globe. 100%.
Would you say that use the
Take two.
scientific method?
Let me help you.
sure.
Take two GPS locations on the Earth. You got longitude, latitude here, longitude, latitude there. If you want to calculate the distance between those two places on Earth, you must use spherical geometry. You cannot do it with Euclidean geometry. It's
Yeah,
impossible to do it on
except
flat.
if I want to tell you the height of a telephone pole and I know my distance from the telephone pole, then I could just use Euclidean geometry, can I?
That's nothing to do with the distance from one latitude longitude to another latitude longitude. GPS locations, two GPS locations. You want to find the distance between those two places, you must use spherical geometry. You
Of
cannot
course you
use
would, because you're taking it off of a celestial
right. And
sphere. There's no latitude and
it's
longitude
not a
lines on the
celestial
earth. Do
sphere.
you
It's
think that
the
we
ground.
walked the earth and found a line called
It's
the
not.
equator on the
It's
ground somewhere?
It's not. It's the ground. It's not a celestial. I go there and I go there and I drive. I will get the right distance. The GPS is
That,
not. It works perfectly.
what measure of accuracy are you going to get the distance within what accuracy?
My GPS works within 1 meter.
1 meter of accuracy. So you're saying, no, not using the GPS. I need you to test the GPS with something else. Like you said, your
I
car.
have. I know
Yeah,
the
your
distance
car.
between
Okay.
where my destination and when I drive my destination to my university every day. You think I don't know the distance to it?
No,
I
I
look
think
at
you
I
do.
can see
I
the
think you do.
odometer in my
Now,
car. The odometer in my car matches what the GPS says exactly to 1
exactly.
meter. Yeah,
1 meter. Exactly. So your
1 meter.
odometer is more
Oh my
accurate than
God.
GPS, or has the same accuracy. That's crazy, because if you read in the manual of any car, your odometer does not have the equivalent accuracy of
Mine
GPS.
does. Mine does.
Oh, okay. Yeah, you
Mine
got a
does.
special one, right? You're a
I've got a
special
pretty
Professor,
pleading
expensive
now.
car. Yes,
Professor's starting to get feisty.
I've got a
He
very
feels the
expensive car.
cooking.
It does.
He feels the heat. He's getting cooked.
Yeah, dude. Okay, so
No,
you think that it
nobody's.
does, and it
I
measures
think
out. All
he
of
doesn't
those
want to.
measurements are taken off of 60-to-1
And
ratio. So we
that means
I
derive
don't.
yes.
every
I
single
don't care
measurement
about your
off
60
of
to
the
1.
sky, and the latitude and longitude positions are because we say there's GPS on the Earth from those stars.
So you
Now, it
don't think
doesn't
we can figure out
surprise
the
me that you
distance?
would have to take spherical geometry into account, considering that you use the celestial sphere to create all of the
No,
latitude and longitude
no, we
lines.
don't. No, we
Wait,
don't.
Oh, where'd you get it from?
Latitude and longitude was created in 160 BC by
With what?
Hipparchus.
Yeah, using what?
Hipparchus, Hipparchus created longitude and latitude on the
Yeah,
Earth.
with what? Using what?
measuring the linear distance from A to B, which would mean that, not in relation to a curve.
All he did was model a sphere and break that sphere up into 360 degrees.
That's right. That's called the celestial sphere. Nobody's
No, the
arguing that
celestial.
when we look up in the
He didn't
sky,
use
We're
the
it
going like
looks
celestial.
right
like a
on
He's talking
sphere.
time.
about the sphere
Nobody's
itself.
arguing against that, dude. Are you kidding me? In order to make
What
latitude and
celestial?
longitude lines, you have to take angle measurements to the sun.
No, you
No,
don't.
Oh
to the
yeah, prove
sun.
it.
What?
Prove
Oh, that's
it.
wrong as
Get
Run
hell.
me
it.
your
That's wrong as hell.
latitude without looking up at the sky. Look straight down at the ground and you tell me your latitude and
We're not.
longitude. You got no
Not
GPS,
a
you got
problem.
nothing.
You can do it
Not a
with you
problem.
can do
I've
it
got
with
a
a
GPS
pendulum.
receiver in my hand.
Well, you can do it with a pendulum. You can do it with a Foucault
Or I
pendulum. You
can
can
do it with a
calculate your
pendulum,
latitude.
exactly. I can get my latitude with a
Yep,
pendulum.
and then that
I can get
what
my
is the
latitude
pendulum
with a
accurate
bunch of
within?
weights.
Yeah, within how many degrees is a pendulum accurate?
You could
At
definitely be
least
within
1
a
degree.
degree. Yeah, it'd be within a
Is it?
degree.
Are you sure? It's within a degree? Are you
Yeah.
sure?
Yeah, there's
Yeah, at
colleges.
least
Because it
There's a
one
is.
video
degree.
where college
Probably
students
better.
replicated this in a
Non,
stairway, and
Probably better.
they got their latitude to
Torah with
within a
non
degree.
sequiturs. Torah with all the non sequiturs. Just the hypocrisy.
You're
Crazy.
just talking
What non
rubbish.
sequitur have I? What part? Well, in order to say I'm using non sequiturs, that means my premises. I had to make an argument with premises, and then the conclusion doesn't follow. So if you could just go ahead and repeat to me my argument with the premises and the conclusion that does not follow, that'd be great.
Yeah, they don't understand the terminology. Are you absolutely sure, Tura?
Absolutely sure that we derived all distances from 60-to-1. Yes, I'm absolutely sure about
And
that.
how does that debunk the globe, though? With distances.
Dude. My point is, when you're saying these distances are accurate, they're accurate
Yeah.
dependent upon 60-to-1. If
We know
someone
how
else
far
wants to
we
go
know.
out into the world and create a different ratio and then say that instead of calling it miles, they call it lees, for example, they just call it lees, like it's a lead, it's a lee away, then they can make a model just the same by using those ratios and just rewording it into
But
lees.
if the distances were wrong, then the time to get there would be different also. Don't you believe that?
The time and the distances are all based on the same thing, dude. Where do you
Oh
think we
my
get
God.
time
Well, what
from,
what
bro?
time do we use? The regular time, right? We all
Use
agree
the
on time,
sun,
right?
dude. You want to talk about
We all agree
sundials
on
and
a
how they
stopwatch,
work?
right? We all
You want to
agree
talk
on
about how a
stopwatches, right?
sundial works real quick and a moon dial and how there's no
Torah,
mechanical difference between the two?
Torah,
Is that
yes
what you
or
want to
no?
get into?
Torah, yes or no? Do we all agree on stopwatches? We all agree on how long 5 seconds is, right? Yes? No?
Oh, we definitely
I
don't.
would.
You've clearly never heard any of the time dilation arguments, I guess.
Oh my God. Here, do
Yeah,
we
in
not
five
agree on
seconds.
what
When
5
you're
seconds
saying
is?
if we count like one Mississippi, do we all agree? No, people in here say all the time, "I'll be back in 5 seconds," and they're not back in 5 seconds.
I
So
see you
therefore, we don't
don't want to
agree.
go down this. You don't want to go down this road. I agree. I see why. Because you have to agree, and you don't want to.
I agree that 5 seconds is 5 seconds. Now, will you
Exactly.
shut
So
up
why?
for 5 seconds?
Now, 10 minutes is 10
Oh,
minutes,
look,
right?
it looks
1
like
hour is
five
1
seconds
hour.
doesn't work to you.
Well, this is their backbone, Torah. They have nothing else if you take this away from them.
No, we have plenty.
Not really. This is the last of it.
This is just one piece of the
No,
puzzle.
once we kick the leg out of this chair, dude, you're literally on the floor. And
Why
it's
does
being kicked out if you stop interrupting.
why does the
One
Google
piece of the
Maps
puzzle.
API have spherical geometry concepts?
Because
Yeah,
it's a
but what
celestial
is
sphere
spherical?
model.
You guys are pretending
Hey,
that space is
listen,
bending.
Yeah.
You're
regardless of
pretending
what
that as you
color-
measure the XY coordinates, which is truly a two-dimensional plane, you pretend that it is bending. So latitude and longitude is
Mhm.
bending due to 3D
That was a
space, not
true
because of what you're measuring along the surface.
NPC reset.
No, that is exactly what you
No,
do.
no,
You
no.
jump
What
from
he did before you
Euclidean
said that.
to
What
spherical.
he did before
You
you said
jump
that.
from Euclidean
Oh,
geometry
the
to
baby's
spherical
crying.
Where
geometry.
he pretended he forgot he reset and forgot that the spherical geometry is from a celestial sphere.
All right, I'm going to read this. I just dropped it in the live stream chat. Spherical geometry concepts. The images within the Maps JavaScript API are two-dimensional and flat. The Earth, however, is three-dimensional and is often approximated as an oblate spheroid or more as a sphere. Within the Maps API, we use a sphere, and to represent the Earth on a two-dimensional flat surface, such as your computer screen, the Maps API uses a projection. Blah, 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 blah. You can read it all. I mean, I posted it
Okay, no
about
problem. Our
9 minutes ago.
GPs, when I say Polaris is 90 degrees above the geographic North Pole, can you prove that with absolute certainty?
You're doing the absolute thing again, right?
No, I'm not. I'm just
Yeah,
asking you, how do you know
no.
GPs? How am I supposed to take solar noon to mean that the sun is directly above my head? How do you know that?
Look up.
Look
Look
up.
up.
Measure.
Oh, okay. And so
You
Solar noon
therefore
is not
light
the
is
sun
So,
not
directly over your
bending
head,
you
by
know
the
what
anymore,
way.
else
right?
you can
you
do?
can get
So light doesn't bend when it's up right above my head?
very,
You know
very
There's
what
Solar
else
no
noon
you
is
can
when the
do?
reflection.
sun is at its highest,
I
when its
was
highest angle for the day. That's your
Yeah.
solar noon when it's on your
so
meridian.
Yeah,
I was
and it's
lucky enough
8 minutes from that spot, right?
so I was lucky enough to experience Lahaina noon, right, in Hawaii, which is when the sun is directly above me. So yes,
Yeah, and that
you can
proves
measure it.
that you can't get your latitude within a half a degree.
Says who? I measured my
What are you
latitude
talking
also using
about?
Polaris.
The high and noon destroys your guys' worldview because it shows
How is
plums
that?
being parallel.
How is that?
It shows plums being
When do
parallel
we use?
across 30 miles.
And first of all, how do we? I wouldn't use the sun to measure my latitude.
Oh, how'd you get Lahaina noon? Did you use the sun and shadows?
No, I took a picture of shadows of something that was supposed to have a
Yeah.
shadow and didn't.
Yeah. Okay, yeah. And the thing next to it also didn't have a shadow. That shows plums are
That's
parallel.
because the sun is really far away, guy.
Yeah, and the
That's because
Lahaina
the sun is a
noon
half
is
a
just
degree
because
large. There's a
If
half a
you,
degree large in our sky, and
oh
there's a half
God,
a degree area on the earth, which is 30
oh
nautical
God,
miles. That is
are
all
you serious?
plum.
Are you
if you
Plums
use
are
the
serious?
more
all
precise,
parallel.
if you use the more precise way to measure the actual position of the sun at Lahaina noon from these 32 miles apart, you would absolutely see a measurable difference.
Okay, if it
Yeah,
is the case that solar noon
you'd
means
need
the sun is
Hey,
something.
why
directly
is there
above
no
your head, the sun is eight
You would
minutes
need some.
before that. So you're
why
in
is
You
there
would
trouble
need
there.
something.
the image I put up?
You would
Where's
need
the
something
sun
so
on the
precise
image
to
in
use
that
it in
shadow?
geometry.
Or on the
What's up, Michael?
so you did it
Here we
again?
go. Here we go. He does it on purpose.
I was trying to
Yeah, he
make
needs
room
to be
for you.
a
What's
fucking banned. This is so goddamn stupid. I don't give a shit what his excuse is. He needs to stop it right now.
Like, come on, Torah. No one would do that to you, right? If we found out like your first name, like, have some fucking respect, man.
He's a fucking idiot.
Oh, calm down, Angelo.
Yeah, change your name then. Quit being a crybaby.
Fuck you. My name's Great Angelo. There's explanation points in the front and back, and it has nothing
Well,
to do
whether your
with
name
what
is
he said.
amazing,
I
magnificent,
don't want to
Angelo.
argue this point anymore, so shut the fuck
All
up.
right. Well, whether your name is Angelo or Michael or Raphael or Leonardo, it doesn't matter. Either way, when you go to measure the distance with a plane flight, first you have to presume that you're doing a Euclidean type of geometry when you're measuring the angles, when you're trying to triangulate your position using the sun. And then you jump and you make a leap of logic and you say, we're in 3D space, and every time I change my position, I'm bending around a ball. That's not what's observed. That's not how you make the first order measurement.
Okay, sure. Anyway, here's my pictures from Hawaii.
You don't use Euclidean geometry, you use spherical geometry.
Oh, wow. You don't presume that the ground is a plane in front of you when measuring angles.
Yeah, well,
You're
plane flight
measuring
routes, they don't
distances on a
calculate
sphere,
them.
so how would you use Euclidean geometry to do the great circle
Oh,
route?
so you're not triangulating angles to the sun anymore? Cool.
Not for flight routes, no. We don't. There's no triangulation for
I know.
flight
That's
routes.
then why did you reference that?
Because you were talking about planes.
No, I wasn't talking to you. I'm talking to Angelo.
I never even mentioned any of that, so I don't know where the hell you got that idea.
Oh, where did your latitude longitude system come from? Angles to stars. Okay,
Even to
so
the
now
degree
when you
that's
traverse
true.
and
Hold
you
on.
measure,
Even to the degree
you
that's
an angle
true.
changes to a star.
Even to
the ground is
the
bending.
degree that's true, the people that created that system
Yeah, I
still
know what I'm
believe
saying.
that there was.
I don't need to hear your.
Okay,
I
thanks
don't
for
need to hear you
interrupting.
catch up.
Thank you for
Jesse,
interrupting.
let him talk, for fuck's sakes.
It's all right. He does this
He's
and then he'll get
catching up. He
timed
can just
out.
catch
He'll
up
get
in
timed
silence.
out because he doesn't know how to have. He has no self control.
Yeah, you
What
can
I was
catch
going
up
to
in
say is
silence,
that.
Pfinky. We know you don't
All
understand.
right, it's my turn to
Okay.
talk. It's my turn to talk. Even
So you're
to the
learning.
degree that that's true, even to the degree that that's true, those people still believe that it was a celestial sphere
Your
with
beliefs
a
don't matter.
sphere inside. You're still cutting me off. With
Okay,
a
we don't care
sphere
what you
inside of it,
believe.
you can find
We care
old
what you can
pictures of
measure.
it. So basically, the own people that you're citing disagree with you.
So we went from distances to sun's shadows for Lahaina noon. Not sure how we did that.
They don't like talking about distances.
I mean, it's that simple. We understand that distances on the surface of the Earth. We know how far away things are from each other. Flat earthers use those distances all the time to claim, "Oh shit, we see this far. We see this far. No curvature." But apparently, when it comes to flights or anything, oh, now we don't know the distance. Now the distances can't be known. Every time they get those distances saying we see too far, they always have to use Google Earth.
Yeah, it's an internal critique. I know you guys don't know how they work, but
I was
you
just gonna
guys
say
are
that.
claiming a certain distance. Hello, guys, please don't interrupt. You guys are claiming a certain distance in the globe. We're just using that distance and showing how far we could see. That's all there is to it. It's called an
So you
internal
guys
critique.
you don't actually trust those
That's all.
distances. You're saying like you think the Google Earth distances could be wrong or are wrong?
They could be wrong. Yes, I'm saying they could be wrong. I'm saying they
Do
are
you
wrong.
is
Yeah.
there any place is there
about-
any place on Earth where it's wrong? Like that we've identified?
It would have to be
What about
everywhere. It would have to be wrong. None of the distances could work if it's not. Is this the part where B-ball interrupts me every single time I go to talk, or
I
what's up?
stopped.
It's like
I stopped when
mumbling
I heard you
background
talking.
noise through the actual
I
combo.
stopped.
Like
I
all
stopped
you
when I
are
heard
is
you
like
talking.
background noise through the actual combo, dude. Like no one can hear you. It's all mumbly. It's all faded and distant. Like
All right,
you
let
just
me
let
switch
people
up.
talk and then you go, or what's
Let me
up?
switch up. Let me switch up. And I
You let people
stopped when I
talk
heard
and
you
then you
talking.
go. Is that cool or?
I stopped when I heard you talking. Go ahead.
So what's the rebuttal to the internal critique point brought up? You guys just
There
eco
isn't one, dude. They don't have any rebuttals for
yeah.
anything. It's brutal.
I do
It's
have
rough.
I mean it's
So that's how
the
we
rebuttal
move
is
from distances to talking about shadow sets. And then they go, oh, because they don't like talking about distances. It's fucking just mind baffling how these people
Let's talk about
are
distances. How
so
do you
fucking
guys
salacious.
like because we can drive in a car. Cars have an odometer. This is an external critique that we can apply to the internal critique. So it's fair for us to say take like relatively straight stretches of highway. Have you ever heard of a case where somebody ran out of gas and they're like, "Holy shit, my GPS said that I was going to travel 100 miles and my odometer got to like 200 miles." Right? We never ever ever hear of this anywhere on earth.
And if this is the case, then what about the those? Oh, we see 50 miles to the Chicago skyline. Apparently, those distances are correct.
Dude, are you that dense?
Yeah, I'm that
He
dense.
just
He's
addressed
still doing it.
why.
I know. I just addressed that, and he's not. They don't understand how an internal critique works. It's absolutely
Yeah,
absurd.
Oh,
he did
either they're
another
correct or
full
they're not
blown
correct.
NPC reset.
Either they're correct or they're not correct. Which one is it? It's like when you
Yeah,
guys want them
you're
to be
just
correct.
demonstrating how you
Hold
don't
on.
understand.
When you
Alan
want.
just did it in Alan's last thing. He literally just did it. He did an internal critique of Jupiter and the speed of light, and
Yeah,
we had people in the chat after saying, "Ho ho ho! You guys think Jupiter's far away? That means stupid."
I'm sorry that you actually agree with any of those guys, but anyway, it always works when you guys want to claim we see too far. Here's the distance. It's blah 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 miles when they measured it out on Google Earth. But then when we say, well, this look at this distance between these two airports, oh, then now we can't use
We
those distances
yeah, we
because they
got the
can't
point,
be verified.
and we got
Yeah.
the point, and you're further demonstrating that you
So
don't
fix
understand
so,
what it.
so figure it
So
out.
you're going to cut me off. So you're further demonstrating you don't know what an internal critique is.
Well, figure it out. Either they're right or they're not right.
Figure it out. That's your response.
Yep, that's my response. Either the distances are correct or they're not correct.
You're dense, bro.
What's the internal critique for Jupiter having like 90 moons that you can watch orbit it?
I was using a distance as the example. I don't know if there is an internal critique with it, whatever moons, but there is an internal critique of the distance of it, and that was being the rebuttals were, oh, so Jupiter, you guys think Jupiter's far away now? Just Paul's doing with these distances, like the same thing. Like, yes, I mean, do you know how internal critiques work?
I was using that word. I was using that phrase with like a little bit tongue in cheek. I was actually just asking, what is the explanation you guys would give for the fact that there's like 80 or 90 orbiting bodies of both Jupiter and Saturn?
We don't assume anything about the distances anymore because we have radar. We know the distance to the sun very, very accurately because we have radar. We know the distance to planets because we have radar. We know the distance to the moon because we have radar. We don't
Yeah,
assume
you're
these things
presupposing a lot
anymore.
of you're presupposing a
No,
lot of things when
we don't
you
have
say
to
that.
presuppose anything. The radar
Oh,
is
we don't.
accurate. No, No.
Walk us through it step by step. How'd they do it?
No, don't.
How did they
There's
do
no
it
point.
scientifically?
There's no point. You don't want to know how they did it because you're just going to deny it anyway. So there's no
No,
point even
because I'm going to point
asking.
out. I'm going to point
There's
out
no.
where the scientific method has been skipped over, and then
All
you guys are
right,
going to say,
you're going to
Amphibious.
point it out
"Oh, you're
because you definitely.
smarter than the
You,
physicists." And the
yeah, you
dude,
are
it's
right.
fucking laughable.
Are
You
you saying
think
because
the radar
there's
doesn't
like no
work?
independent variable?
You think the radar doesn't work?
Yeah, that's what he thinks.
No, I think
Amphibious.
you're
In
making a
night.
lot of presuppositions, much like spectroscopy. You do the same thing. Everyone
Right.
does the same thing. They just because
Sure.
it's circular reasoning, dude. You say the stars are made out of these materials. They're composed of all these materials because that is what we see light break into. You don't take anything else into account.
All right.
What it
Like what
moved
should we
through.
take into
You just
account?
say you just
Do you
said
know
Like what?
there's other things on Earth that use spectroscopy also, not just
Exactly.
for looking at stars?
yes on Earth, and you pretend like
And why
anything
would
out
that
in
be any
space
different?
acts the same way.
Why would that be any different than something we look at in the sky?
You presuppose that everything you see, all these celestial objects, act the same way.
It's the uniformity of
Let's
nature. It's an
say, hold on a
axiom.
sec.
That's a
Let's
basic
say,
axiom of science.
yeah. What I was going to say is,
Yeah, the
what about?
uniformity of
Well, hold
nature,
on a sec.
where a big rock is floating around in the sky and orbiting us. Yeah, that's
At
really
what
uniform in
distance?
nature. Yeah, let's repeat that.
At what distance does it break down? Like, so for example, if I said, "Oh yeah, well, spectroscopy works in America," but that doesn't mean that it's going to work in Australia, right?
There's a
You're willing
difference.
to accept on Earth
So
that everything will be
yes, I'm
consistent.
willing to accept on this realm. If we can't get to, you cannot get to where you are presupposing all these things. You can't verify it for yourself. So you have to take it on faith.
Well, yeah, but we
So,
haven't
for
verified
example,
that these laws of physics work in every single place on Earth. We just
you
assume that
okay?
it will.
And we understand orbits really, really well, which is why the 80 moons that orbit both Jupiter and satellite have predictable paths that we can map, and we can predict when
Not
moons like
exclusive to a heliocentric model.
doesn't matter. It's not exclusive to Earth,
Well, let
right?
me ask
That
you.
was your
Yeah.
critique.
No, that's not.
And so we can predict. We can
You
predict with
missed my
very,
critique.
very.
Just because
We
you
can
make
predict.
postdictions
No, we can
doesn't
predict.
address what I was
No,
saying.
we can actually
Okay.
predict when moons will go across the surface of Saturn
And
in
how
such a
do we
way
do
that we
that?
can plan years in advance for one specific hour where this is taking place, and we can record it with our telescopes and publish it
Yeah,
publish
because
it on
it's
the
happened
internet.
in history. It's happened in the
Well,
past, and we have a
what about
pattern
what about Shoemaker Levy though? That was a unique situation, and it was
called a
announced at this
postdiction.
time. At this time, this comet will hit Jupiter, and you will see, the atmosphere of Jupiter. The impact craters or the impacts are going to produce atmospheric effects in Jupiter, and all the amateur astronomers in the world tuned their telescopes and it predicted this event that had never happened ever
That's a good.
before. Was that a
Yeah,
prediction or a post-diction?
yeah, yeah. That's a good point. There's been a few comets in the past few years that have never come around, and they were predicted.
Yeah, I'd have to look into that specific instance.
What about amateur
So maybe,
radio?
but is
Amateur
that
radio people who
would that
basically
be
bounce signals off the moon.
exclusive? Would that be
Hold on, say that
exclusive?
again. Say that again, Great Angelo. You
Oh, we're bouncing off the moon.
Amateur radio operators, including myself and my father, back in the 1970s, not only listened to Apollo, but we were able to bounce radio signals off the moon and time them coming back and calculate the distance to the moon. So
is that fallacious or not?
no, that's absolutely a fact. And
no. There's a presupposition fallacy
you
in
can
there,
do it too.
and circular
You can do it.
reasoning in there.
If you
do
buy
not
yourself a
see that.
Moonraker antenna that basically will
No
give you a
one's
horizontal
arguing that if you
and vertical
bounce,
signal, you
no
can
one's
bounce it off the
arguing-
moon
Hold on,
and
no one's
time it.
arguing if you point at the moon, you'll get something back. You're presupposing that it's traveling out of our atmosphere through space, bouncing.
Where else would it be going?
Actually, the moon is in our
They're
atmosphere.
pointing it in the sky. Where else would it be going?
If moon's in our atmosphere, then you
you're
should accept that.
presupposing
You
that
should
you
accept
know.
it then.
The time would be so much shorter.
Presupposing how you know. That's another false
Oh God.
just expectation.
I mean,
No,
Just because
here's
you've
how
been
I know.
brainwashed
Okay,
to think
I'll give
how
you.
everything works.
Hang on.
Why
I'll give
not?
you the exact. I'll give you the exact way how it's done. You use what's called a variable frequency oscillator, which means you're transmitting on one frequency and receiving on the other. The other station that's going to receive your signal is going to be receiving on one station, the station that you're transmitting on, and transmitting on the other. So when you transmit to him, he's going to send a signal back to you as soon as it arrives to him on the other channel that your VFO is picking up. You time the amount of time it takes for you to send your signal, and when you receive a response, that all bounces off the moon and comes back to you through him. You can figure out the distance, triangulating the distance between you and him and the distance to the moon, and you can figure out how far the moon is. It will come out to about 2.5 seconds total time, and that puts the moon at about 280,000 miles away.
A whole lot of presuppositions.
It's not. Where's it a presupposition?
Okay, well, hold on. Because a minute ago, hold on a second. Because a minute ago you said you think that that everything works the same in this realm, and then you said the moon is in this realm. So why would you not accept that light will behave the same going to the moon?
I was just poking fun that the heliocentric model always has to move goalposts, slap on duct tape, fix their model, and just change things as they see
There's
fit.
no duct tape. It's all
You didn't answer my question, though.
Just to make
you didn't
things
answer my
work.
question.
So it was kind of tongue in cheek when I said, "Oh, now the moon is in our atmosphere." Technically,
Well, it is. Is it not? It's not.
yeah,
It is
so-
in our realm.
so
Hold on.
according to-
It is in our realm. So why do you not accept that?
It's
the
not in
laws
our
of phys-
realm. I don't buy that shit. I was tongue in cheek saying that. Are you that dense?
Where do you think the moon is?
I don't pretend to make. I don't make any claims about the moon.
But,
Then
but you are making a claim. Hold on a second. He is making a
Go
claim about it. The claim you're making is that the moon is far enough away that we can't trust that the laws of physics will hold.
No, I'm saying you can't go there to verify anything about it. You can't even verify that it's physical. No, that was a fraud, and we were all hoodwinked.
If you get the radar signal off a jet, are you going to say that's presupposition, or is that jet actually there and you get a signal back?
Yeah, it's fallacious.
Can I jet pack up to that jet? Right?
No.
Like
you see it in the scope,
I think anybody's
physically,
nobody's
I could go
jet
there.
packed up to a jet that I know of.
Yeah, they've worn a rocket.
Well, you shoot it down, and then we can decide whether it was real or not.
And then they flew next to a commercial airliner. They've done that.
So basically, you have to physically go up there and touch that jet just to make sure that it's there. That radar signal that you
said
how
came
back works. And told you it was there.
Yeah, that's kind of how the scientific method would require.
No, that's not at all how the scientific method works. Let me explain to you the scientific method.
So to pretend like we know everything about space.
I'm going to explain it to you because I'm actually a scientist. I'll just go ahead and tell you flat out where this particular application of scientific method works on the moon. You have an observation of an object up in the sky. You decide you want to find out what this object is either made of or how far away it is, how it's traveling and so forth. And the first idea that pops into your head is, how can I measure the distance? Well, I happen to know that light waves and electromagnetic waves travel at approximately the speed of light. It's a constant. So I can measure the amount of time something bounces off of it, if I can get something to bounce off of it, and bring a signal back, figure out how long it took for the signal to go out and back, and then I can measure a distance. As far as size, angular size, after I figured out the distance, is how much of the sky it takes up as it's out there away from me. So now I figured out its size and its distance.
Can I stop you, please?
Go ahead.
So what was the experiment where they tried to figure out how fast light moves, right? What was that called? Not Michelson, Morley.
There's a bunch of them.
Yeah, there's a whole bunch of ways to figure out the speed of light. But even if you came close to
it, so
relatively
to pretend that we know exactly how it works is just being false.
What about all the multiple ways of measuring it, and they all agree?
They don't.
You accept it for everything else.
That's the
thing. You accept it for you accept it for any range finding on Earth without question, right? Radar, you can do long distance range finding with it. Suddenly, when it goes anywhere that questions your worldview, you're like, I don't know if that thing works.
No, I'm just being honest with myself. I don't make any claims about somewhere we cannot go.
That's not the point. You're not making claims about where we can't go. You're making claims about the technology right now, right? You're saying, well, how do we know that range finding works? And
wrong.
it feels like
No,
an inconsistent position.
that was a straw man. I never said that.
We can't actually go to this. We can't actually go to the sun as physical humans, right? But we can bounce radar off of it and predict its distance beforehand, and then actually know that it's 93
Disagree
million
with.
miles away.
If you
It's
were
been
being
done. It was
honest,
done in the 50s in like 1958. I have the
if you're
paper on it.
yeah, so if you were being
So you're
honest,
saying I never bounced a
we
signal off
broke
the
down
moon?
that, and we can break down that paper and show where the fallacies were and why it's not a
Okay,
sound reason.
perfect. I'll have it for you in just a moment, and then you can tell me where it's wrong.
When my father and I bounced signals off the moon, you're saying that never happened, or we can't prove that it was the moon we're hitting. Is
Exactly.
that what you're saying?
You were
Well, it's
presupposing that was the
interesting
moon.
because when we turned our antennas ever slightly away from the moon, we never got a signal back. But
Yeah, so
whenever
what
we
if-
were aiming directly at it, we always got a signal back. Something was there. So now
Yeah,
the
but you're
problem is that's something.
presupposing
Hold
that
on,
it's
I'm
a
going to finish what I'm
physical
saying
object.
here. I'm going to finish what I'm saying. That something that was there was approximately 2.5 seconds away, total distance. So as a result of that, we have to calculate how long does it take the light to travel to the moon? A second and a half, and another second and a half coming back, or a little less than a second and a half coming back. Approximately 2.5 seconds round trip, which gave us a distance based on the speed of light, a constant speed that's been well known to science. Whether you want to deny it or not, that's
There
fine.
you go. Well,
What you're denying is the odds of there being something other than a vacuum between the sun and the earth. Turn red, that is considered to be redshift because it's being scattered. What you guys claim is redshift is only strictly due to distance. You like to only attribute redshift to the amount of time it is traveling in an apparent vacuum. But I'm here to tell you things can shift to the red side of the spectrum due to attenuation. Just Google it. Just
he's here to tell us.
Google it.
You're here to tell us exactly.
Possible explanation of why there's red shifting. Yes, attenuation can make objects appear red because it eliminates the other light waves that are coming, such as the blues, greens, and yellows.
Okay, is there
We
absolute truth
base
in the
our
world?
work on the
Does it
word
exist?
confidence.
Wait, is there absolute truth in the world? Does it exist?
This is you running,
No,
by
it's
the way.
no
No,
truth.
it's
Fine.
not, because that's what I'm
Only-
looking for. And if what you're
only
offering
logic
is
and
I'm
math.
not
No,
really sure,
don't
I
come
only
to
know
me
this
if
to
you
the
want truth.
dude. Stop talking.
let
You
Torah
guys are saying
finish.
you only know all this to the extent that you could be wrong about it, and then we go, hey, I think you could be wrong about it, and you get all up
Yeah,
in arms about it.
Finish.
Saying you only know all this to the extent that you could be wrong about it, and then we go, hey, I think you could be wrong about it, and you get all up
yeah.
in arms about it. Okay,
No,
so that's
No,
the problem I have, and that's why I would never accept your side, because you're admitting that you could be wrong about it, and then when questioned on it, you double down like it's actually
we
true.
can't be wrong that the earth is a globe. You understand? There's certain things that we can't be wrong about.
You've
We can't be
inductively
wrong that
figured
the
that
earth
out.
goes
You
around the
don't even
sun.
have dude, you don't even have a deductive argument to prove the earth is a globe. All you have
Of
is
course I do.
induction. All you have
if
is
I told you,
a couple
Of course
people
I have
going,
many
"Oh, you're
arguments
an
to prove that the
astronaut?"
earth is a globe.
This is a big step forward, I think.
that's
Yeah,
true.
to show you they're wrong. Oh, you're
Arguments
an
to prove that the
astronaut?
earth is a globe.
You're an
Okay,
astronaut?
been an astronaut? Have you taken the time to go meet one? Maybe you ought to go meet one
Yeah,
and find out if
I
they
live
actually went
just
there.
south of Cape Canaveral, dude. I go there
I
all the
have
time and talk to the
personally.
Try
astronauts.
not to get punched when you talk to
Listen,
him.
Yeah.
listen
No
to
one
this,
here
okay?
has seen the Earth firsthand.
So
Yeah,
Torah,
but I
let me
mean,
ask you this.
I'm happy that like flat earthers are accepting orbital mechanics for Jupiter. This is a big step forward, I think.
That's true.
Yeah, to show you they're wrong.
Yeah, like let's say they're wrong on the orbital mechanics of
Joe,
Jupiter,
look at your
and you
orbital
guys prove it.
mechanics.
Hold on. Let's say that we're wrong, and Shane and Alan prove it. Well, we'll figure out a better number, but at least we all can agree that there's things orbit and there's orbital mechanics. It's a good thing.
Yeah, exactly.
You understand
We,
it's
we
based,
see them.
the discrepancy is based on if the AU and the speed of light are correct. So you're like, oh, if you find a little discrepancy, no problem, we'll just make an adjustment. 1 AU is firm. You can't change it. Speed of light, firm. Can't change it, dude.
Yeah, so
Yeah,
what
Yeah,
happens
so
if
you have
speed of light
What
is
do you want it to
discrepancies
be? What do,
constant.
within
what do you
your
want the
own
AU to be,
source.
Torah? I'll change
what
it right
happens
now.
if there's gravitational if there's a gravitational field that we're not aware of?
Is that bending the light? Is that what you're saying?
Mm-hmm.
Yeah. Well,
Bending the light
maybe
of the
one of the
moon.
moons. Maybe one of the moons of
Bending the
Jupiter is
light of the
bending the light.
moon. Bending the light of the moon that's being reflected onto the moon by the sun.
On the Jupiter's moons.
Yeah, it's bending that light. The sun is shooting light to the moon. It's hitting Jupiter and having to bend into Jupiter, right? Because the light's going to go the denser part, you're saying?
Of
So
course,
then,
yeah.
therefore, we're going to see it later
No,
because no one
Jupiter.
calculated in that refraction. That
Just
doesn't
shut
help
up for
you
a second
when
and I'll tell you.
I mean, it could be
one
an
of the
ether.
moons
Hey, it
was
could
a
be an
Let me
ether
let me
negative.
just
field.
help you a bit.
Maybe it's an
Let me
ether
just help
field,
you a
and this
bit.
brings us all
Okay,
together
I
with
could
Jupiter
Torah.
buy that. I could buy that.
Jupiter
Then.
is a huge planet. Jupiter is a huge planet with a huge gravitational field. Okay, all right. So
It's
if we
smaller than
see
my
that there is an
fingernail. What are you
anomaly,
talking about?
if there's an
The eff-
anomaly with Jupiter, that could well be have to do with something different about its gravitational field. Okay,
Jupiter's
so
smaller than my
that doesn't mean
fingernail,
that we're
dude.
wrong. It just means we're not accurate. We're incomplete. The incomplete and wrong are two different things. Science doesn't have a truth. Do you understand? That's the first thing I tell my students when I walk into the lecture theatre. The first thing I tell them is there's no truth in science.
Wait, is
We
that
go
true?
by we go by confidence. We're
Is
either
that true?
very confident.
No,
Is it
I have
absolutely
a
true?
quote from Neil deGrasse
it
Tyson.
is true
I
as
have a
in everything
quote from
except
Neil
mathematics
deGrasse
and logic.
Tyson. Can you guys hear me? I
Yeah, go
actually
for it.
have a quote from Neil deGrasse Tyson. Can you guys hear me?
Good. I'd love to hear this out of context quote. Go ahead.
It's not out of context. He said that once you have experimental consensus, you have a new truth about reality. That's not out of context. That was just a poisoning the well fallacy you just did. But
No, there's no. We don't have truth in
that's
science.
verbatim what Neil
Anybody
deGrasse
who says
Tyson
truth
has
in
said, the
science is
greatest
taught doesn't know
science
what they're talking
communicator
about.
of all times. Now we're supposed to just buy some guy from
Well, that would be
who
your
knows
opinion. I don't
where
consider him
saying
the
that.
greatest science
Can you guys
communicator of
hear
all
me
time.
talking? Hello, hello. I'm just trying to make a statement and then I'll be done. Please. Now, are we supposed to buy some guy's word, some random dude on Discord, or Neil deGrasse Tyson, the greatest science communicator of all times?
Well, if that's
Neil
a
deGrasse
question,
No,
the
it's not
answer
the
is
greatest.
he's not
He's
the
probably
greatest
one of
science
the best.
communicator of
He's
all
I
time.
trust
I
him
can
over
think of
these
several
guys.
scientists who are better than he is.
I
The
think
rest
Bull
of us
Knight's a better
scientists
communicator than
definitely
Neil
don't
deGrasse
think that
Tyson.
he's great. Okay, the
But
I beat
this
rest of
is
him
the
at
us
thing.
physicists,
Okay, Dr.
I'm
Phil.
not impressed with Neil deGrasse Tyson.
Yeah, we know you're not. We have a quote from you when somebody said water vapor is a gas. You said that's the silliest thing I've ever heard.
No, you didn't get a quote from me, and you've taken everything I've said out of context.
I
Okay,
have a quote right now. I'm
ask me the
right
question
now.
again.
Jeremy, you're
Jeremy,
breaking
you're
up.
robot. You're
Yeah.
really
Ask me the
bad.
question again. Ask me a
Hey,
question again.
Professor Phil, this is the problem with what you've been saying is earlier you told me the distance to the sun is a fact. Did you figure that out through science, sir?
Yeah, within so many significant figures, yes, it's
Yes.
a fact. It could be out a little bit. It could be out by I don't know 20 or 30 decimal places, but within
Is
our
that true?
significant within the ability of our significant fact, I am very confident that what we have is correct.
Is that true?
I don't call
Should
it
I
truth.
believe
I
you?
just call it.
Should I believe you?
Yes, of course,
Quote,
because
I
we've
have a quote
measured it.
Yeah,
from
Many
okay, so
people,
you
Torah that
believe it's
says,
many
true,
people have
right?
measured it.
You
Why
believe
shouldn't you
it's
believe me?
you yeah, well,
I,
I should
Why
believe you
shouldn't you?
because you have the truth, right? How'd you
Now,
get the truth
you can
again if
have
you
a
don't have
I
science, my
didn't
consensus. You
say
brother?
don't
that. I didn't
necessarily
say
have a
that.
belief.
I didn't use the word truth. You did.
But I should believe it, shouldn't I? I should believe what you believe, right?
No, you can agree
I'm
with it.
saying I'm saying that we measured it, so we know how far away it is.
Okay,
Now,
so we know
could
it,
we?
so I should believe it too, right? Did we come to that through science when you
Do
said
you
we can't come
understand
up
that
with facts or truth through
our
science?
do you
quote
understand that
from Torah
our
that says that
instruments have
Jupiter is the
limitations?
size of Torah's fingernail.
Do
Torah is
you,
Jupiter the
okay.
size of
Smaller,
your fingernail, and
smaller.
how did you
It's
establish that?
small. It's smaller than my fingernail because I put my fingernail in front
How
of it
did
and
you
it
establish that?
disappeared. Yeah, I put my fingernail in front of it and it disappeared.
Do
Okay,
you
like if
understand
you
that
put
our instruments
I
have
put my
limitations?
neighbor's house disappears behind my fingernail. Is my neighbor's house smaller than my fingernail?
No, good point though, right? We probably shouldn't be judging these things just by brightness and distance.
Oh my God, he can be taught.
If there's no
See?
truth in science, what's the point of
Unbelievable.
science?
So there is truth. This is
The
the
point
problem
is to
is you
get
guys
us
think
closer and closer and closer to what we to give us better and better confidence in what we have, and the
To what?
ability to use it, to make predictions. That's it.
To figure out the real truth
Yes.
that there is a creator and then you want to know his whole mind or whatever?
Oh
Because is
God.
that just what, like, that's, dude, when you say we're
If
looking
there
for the
was,
truth, you've already set a standard in your
that
mind to
wasn't
what
his
is the truth.
argument.
And if the truth is
if there was
something
one
that
of
is
those,
not consensus based, if the truth is not something that's consensus based and it's objective, you're looking for the fundamental thing that caused reality. Do you understand that?
no. If I measure the distance of the sun and I get 150 million kilometers, and then someone else does it and they get the same thing. Three other people do it and they get the same thing. 1,000 other people do it and they get the same thing. And then we use that distance to calculate how long the sun would go around the galaxy. And we look at all that and say, okay, the 150 million. I'm pretty confident that's right.
That's correct.
If all the scientists who
I
do it
agree. So
get
now
the
you
same
have a
figure,
fact, right? Now you have a fact
no,
or a truth about reality, a
I
fundamental
don't
fact
call it a
about
truth.
reality.
I just say I'm highly confident.
Should I believe you?
Why not? I mean, do you think
Why
all
not?
these people who
Because I
measured it
think
and
it's
did
the
all the?
only.
You
I'm
think
saying
all these
because,
people?
dude, if I was like, I'm like 99% confident this is, pistachio ice cream and not wasabi. Would you eat it?
This is the issue is that
Well,
Professor
I
Phil has
would.
done this and
if you
you
find
could
another
reproduce it
1,000 people to
yourself.
taste it before me, yeah, if the other 1,000 people said it was pistachio, I'd be going along with them.
Okay, cool. So then at that point, you have a fact about reality because the
Yeah,
consensus has come to agree. A
no,
fundamental fact about
because I
reality, right?
trust I trust the people who are educated and who are charged with doing this job. I trust them. That's how we
I,
work.
I, I know, I understand
We
that.
build our knowledge upon the shoulders of each other. We don't go
I
inventing
know.
new things again.
What if the generation before you didn't have the same compassion and love that you do, and they were actually really evil and wanted to manipulate people? Do you think that they could create this same kind of concept? Basically, they know all of the truth, right? They know the whole thing, the fundamentals, and they know that we don't know the fundamentals. So then they make a method for you to figure out half of the fundamentals. And then they say that's
No,
the real method, but there's actually a method that allows you to figure out all of the fundamentals. And we have them
no,
in our reality. You guys just have refrained from using the
it doesn't
second
work
one.
like that. It doesn't work like that. You see, when I teach something like orbital mechanics, I start right from scratch. Okay, I explain about gravity. I explain about how we measure it. I go through all of that. So gravity, speed, we talk about speed. So my students have to do kinematics in order to understand speed, understand rotational speed. My students have to do dynamics so they can understand forces. My students have to work on understanding the universal laws of gravity in order for them to understand how this works. And then we look at that and we say, well, why can we make a satellite work? Right. It's the balance between rotational speed, in other words, mv squared on r, compared to the gravitational pull of the Earth. And guess what? If you can get that right, then the satellite will remain in orbit in its right. Eventually the satellite will degrade. If it doesn't go that speed, then it will fall to the ground eventually. All right. So we know where to put this satellite because we know precisely. That's why we know we can put a satellite at 36,000 kilometers. It will stay where it is. In other words, it'll orbit the Earth at exactly the same speed that the Earth rotates. This is a model. We know that before we put the satellite up there. We don't. It's not a practice thing. We put the satellite out there because we've worked it out. The model works. So
Okay, I get that. Is it possible that that's wrong and there's another explanation for that being the case?
how come what we did worked?
So
How come what we did worked?
you can have a justification for a belief and it be true,
No,
or you could have
what
like
we
you could have a true belief without a justification. So
It's a bit,
no.
Torah.
sometimes
It's a bit
people
like,
can be
So let me explain
people
to you.
can
okay,
be
I
hold
get you,
on real quick.
Torah.
Let
Let
me
me address it.
explain it. It's people can
We
be
get it.
right and have the wrong justification.
No,
Yes.
no. Listen,
It's
no,
like,
listen.
let's say I have a bike. Well, let's say I have a bike, right? And I learned that like when I get on my bike and I pedal it and I turn the handlebars, then my bike goes forwards and I can steer it. And then it's like somebody like Torah coming along and saying, is it possible that it's a totally different thing that makes your bike travel and steer than you turning the pedals and turning the steering wheel? Or turn the
No,
handlebars,
it's
and I'd
not
be
like
like,
that.
I mean, yeah, I guess it could be
That's
like
what
an
exactly like
ether
that.
field that's like
No.
that's guiding me through my mind, but no, I think it's just the fact that I pedal and that's what happens.
That's a
Uh,
category
Oh,
error because you're
you
saying
mean like the
something I could
car?
get. Oh,
You
so
mean
go
the
ahead.
scenario? You mean like the scenario with the car in the tree where you could just switch the car out for a bicycle and you wouldn't have any idea if you were pedaling towards the tree or if the tree was coming at you, something like that you're talking about?
No,
no,
something
we
something totally
no,
different.
Okay,
we
I'm
You
not
worked
would
out.
doing
so if you
that.
were pedaling,
No,
you
this is
would
not the
know
way it
that you
is.
were moving towards the tree and it wasn't vice versa?
Let me explain to you the way it is. So we worked out that if you can get an object to move fast enough, so say 17,500 kilometers per hour or 28,000 kilometers per hour, if or 22,000 kilometers per hour, depending on where that satellite's going. If you work out that you could get something to go that fast, and you know that it's a certain distance away from the Earth, so you know what the gravitational field strength is going to be. Now you make that model, and then what you do is
You're already
you get a
going that
rocket.
fast.
You get a rocket. You get a rocket, and you send it up there. You put that, and you make sure that rocket goes that fast, that speed. You take it to 36,000 kilometers, and you make sure that it's going exactly the right speed. And then you see, oh, that's good. Now anybody from Earth will see that satellite as if it's standing still. The satellite's not standing still. It's orbiting with the Earth, but it's not standing. But we already knew that it was going to do that before we put the rocket up there. That rocket cost $150 million, right?
Okay,
We knew beforehand what it was going to do.
Okay, that's a possibility that you can make the maths work and then give these other explanations for when it doesn't work. We get it. And then you could come to your belief system of what it is. And you admit that it's not true. But the car analogy or the bicycle analogy is different because the
No, it's
bicycle
not.
is hands-on. It's hands-on. We're doing it. I'm doing all of the stuff. When you're
Yeah,
talking about all this satellites and everything, you
Hold
have to
on. No, you're
hand
not.
hold
that
on.
over. You have
No.
to hand
Torah,
that
hold on.
over.
Hold on.
You have to
Hold on.
hand
Hold
that
on.
Let
over
him
to
finish.
someone. Because you have to hand that
Which
over
part
to
is not
someone,
hands-on?
and you have no idea if they take all of your math and recode it. For all you know, that could happen.
Which
Okay,
part is
no,
not
it's not
hands-on?
you aren't doing all the work. So you're turning the crank, but the crank has little teeth on it that are sitting in the grooves of your chain, and some force has to bend every little link in your chain to make it follow around the curve of the front sprocket to go into the back. You have a hub that's got ball bearings in it. You're not personally turning those ball bearings, right? Like you're not turning either hub on the front or the back. So you're doing part of it, but then something else is moving the rest of the mechanism. I think it's a great
Yeah, all
analogy.
of that stuff is empirical that I can open, touch, see, measure, get diameters, cut in half, look into more. The stuff
Yeah, but
you're
have you
talking
ever
about
opened
is
up? Hold on.
not
Have you ever opened up a bike?
empirical,
Have you ever
dude.
opened up a bike hub and looked at the bearings inside?
Yeah.
You
On a
have?
skateboard, I know for sure that I
Okay,
always.
skateboard's not a bike. Very totally
Okay,
different
but
thing.
so you're saying that because I've never looked in there, that there might not be bearings in there. Is that the
Well,
case?
if what I'm
You
saying
could
is
be
if
right.
you
You
wrote
could be right, but you could be
let me be
wrong
clear what
too,
I'm
right?
asking. You haven't done it. So if you were riding a bike and I asked you, right, could it be something else other than all this other stuff you learned? You learned that there's pressed bearings inside the hub and all that. And it makes sense that that's the case, but because you haven't verified it like personally yourself, you couldn't make that claim. Like, to me, that seems silly. I think we all agree that bikes, they work
On
the
a
way that they work.
bicycle, it does seem silly for sure, but when you're talking about like outer space, it doesn't seem as silly in my opinion because
No,
all of us have the same. Dude, I don't think you get this. Do you think you've had like some superior education or something? Like
no,
I'm missing
I'm
something.
super
Okay,
mid, not very
okay,
smart, and
cool.
mildly
All right,
educated.
so we're all in the same boat, but we have
Well,
different
some of us
beliefs.
are in a
Okay,
higher boat.
exactly, dude.
Like
So
Professor
obviously there
Phil
has
and
to be
Great
some.
Angelo are in a higher boat than
Okay,
you and I.
if those guys think that they're in a higher boat, that's the biggest trick that's ever been played on humanity because we are all brothers, sisters.
Well, I mean, they're in a higher boat as far as this
We're
topic
from
goes.
we are from the same perspective. So when you say that I could look at the sky and tell you, guess what? I can also look at the sky. I can
Yeah, you
do all
can.
that stuff that you do. And then I
Yes,
can
you could
go,
look at
I just
Jupiter
don't
and
buy
see
it.
the
I just
moons.
don't believe the story they have behind it.
Well, but like you can look at Jupiter and see the moons going around it, just like anybody else. You can choose not to look at it if you don't want to, but like
It
it's
doesn't therefore mean your cosmological story of a Big Bang evolution and billions of years is true. That doesn't
it's
mean
not
that,
proof.
okay?
Yeah, it's not proof. I agree. Just that it's the
You
best
don't have
explanation
proof
thus far.
in your worldview.
I know.
Dude,
I
this guy
agree.
just told us for an hour that truth doesn't exist in science and then tried
Yeah.
to explain how he knows all this stuff to be true. It's
Yeah, there's
ridiculous,
induction.
dude.
He uses induction. You prefer deduction. It's kind of two different things, but yeah,
You
there's no
can't
proof. I
have
can't prove it,
induction
but
without deduction. Prove that induction works without deduction.
it doesn't. You definitely need deduction for induction.
Okay,
I
so
agree with
then
you.
why are you sitting there saying we broke the rules of logic and it's okay?
You're saying induction is breaking the rules of logic?
No, without a deductive argument to prove your induction. Yeah, it is.
I don't think that's how it works. I think deduction is used in induction, but it doesn't mean that every inductive argument also needs a corresponding like
Okay.
companion deductive argument to go with it.
And give your argument for why inductive arguments lead to strong and weak conclusions, and not please put it in a deductive form because that way it preserves the truth.
I don't know how to do that. See, when it
Do
comes to
you
this
agree?
boat, when it
Do
comes to
you
the
agree with
boat
that?
of making deductive arguments, you're in a higher boat than I am, and I'm okay with that.
It's
But
just
science is
modus
built on
ponens,
induction.
modus tollens, and reductio ad absurdum. There's only three.
Whatever the argument is that like helped people build computers and satellites and all the stuff that we use, that would be the one that I would call to.
Yeah, okay, pragmatism. All right, dude.
Yes, that's one. The pragmatism
Okay,
fallacy.
so
That's the one I do.
give me the deductive argument that pragmatism leads to a strong. You understand pragmatism is like if the road is wet, it rained. You know, it rained, or if the road is wet, therefore it rained. You know, it rained. The road is wet.
That
You
doesn't
get
feel
that
very pragmatic
pragmatic.
to me.
It's
That doesn't feel
100%
pragmatic to me.
pragmatic. It's
It's
100% pragmatic.
a
My road is wet today and it
false
rained.
correlation.
It
False
It's a
doesn't. I
correlation.
don't
dude.
know. Like I said, you're in a higher boat than me, but saying the road's wet doesn't feel pragmatic. Pragmatic
Yeah,
feels
dude,
more
it is
like
100%. I can prove the reason the road is wet today is because it rained. I can prove that pragmatically. I could show you the Weather Channel. I could show you that it rained here on my rain camera. I could do all that, but I still
Isn't it?
affirm the consequent.
I was just about to say, Torah, that's
But
the affirmative
can you
consequent
prove that
classic, isn't it?
yeah?
If you
Can
type
you
that into
prove that the
Google,
road is
yeah.
always wet and that every time the road's wet that it rains?
No, I cannot prove that. And that's the beauty of what I've been trying to bring up is when when they look at this Jupiter thing, they're not getting the always they should be. So therefore there's something wrong.
Given what you just said, we would 100% be able to tell if we had a car that was parked and a tree that was parked. I can't believe I even just said that, but they're the same distance away from each other, right? They're both on the same ground. And you're telling me we would absolutely 100% be able to tell if the car was moving towards the tree or the tree was moving towards the car?
You need to choose a reference.
But we have this acceleration you just said. We have the proper acceleration with the car. So
Okay, so in that case, the
so you're saying
car
we
is
can
the
never know
only
what's
one that
moving
will
with the
see
car.
proper acceleration. So if you had a car parked and it accelerated into the tree, the car would show proper acceleration. The tree would not.
But you're saying we couldn't actually know 100% which one was moving or not?
You can know which one is accelerating, which one has proper acceleration, but you can't know what your velocity is. The car can only tell that its velocity changed by a certain amount. It can't tell where it started or where it finished.
Acceleration would mean movement. And if we didn't have any movement, any acceleration on the tree, then we would know which one moved, obviously. Or are you saying we wouldn't know which one moved?
Yeah, so you're confusing velocity with acceleration, right? So the whole relative velocity thing is a
I'm not
problem, but
confused.
acceleration has
Not right.
different
I'm not
properties.
confused. Not right. I'm not confused.
So you would agree that the tree shows
I'm not
no
confused.
proper acceleration, right?
Yeah. So would we know that the car moved into the tree, or would we still be left wondering which one moved into the other one?
All we can say is that the car accelerated towards the tree.
That would be moved, right? If something accelerates, it moved, right?
Yeah. So the car knows that its
like
motion is changing.
You guys, it's crazy. Yeah. So it would be moving. Could we tell that it accelerated forward?
From within the car, yes, you can tell it accelerated in a particular direction relative to the ground. Yeah.
All right.
The tree has a different perspective.
You're saying without the ground. So you're saying this is coordinate acceleration, not proper acceleration, because
no,
you're trying to reference the ground.
Experiences both. So if you're looking at the tree, if you're planted on the ground and watching this fold out, the car experiences proper acceleration and coordinate acceleration.
Yes, and we would know that, and so we wouldn't have to reference the ground at all. We would just know that the car moved, right?
You know that the car's accelerating. The car can't tell how fast it's going.
That means moving. Does accelerating mean moving? Why is this so hard to agree on?
So constant velocity and accelerating.
If you accelerated, did you move? If you accelerated, did you move?
You did, yes.
Okay, so I don't know why you keep fighting on the word move, but obviously you would know that the car accelerated, aka moved towards the tree, right?
Yeah, it accelerated towards the tree, yes.
What if it moved at a constant velocity?
Move towards the tree. This isn't 1v1. We already told him. It doesn't work with this guy. By accelerating towards the tree, we would understand that means moved towards the tree, right?
Yes.
Okay, so Pfinky, there you go, Pfinky. A whole 2 weeks worth of your bullshit argument down the drain. We know which one moved.
No, we don't know which things moved. From the perspective of the car, it moved towards the tree.
So you're saying we don't know which one moved still? We don't know if the tree or the car moved?
So the car is exhibiting proper acceleration. It knows it's accelerating. From its perspective, it can still look at it in both ways. It can say, oh, that tree is coming towards me, but because I've got proper acceleration, I can say that I am accelerating towards the tree. And
we would know it's not the tree. And we would know that it's not. And we would know that it's not the tree moving towards you, obviously, then, right?
So we've got two reference frames here, right? We've got an accelerating reference frame and one that is probably inertial or thereabouts. So the car would be able to make a reasonable assumption to say, I have proper acceleration. That acceleration matches the coordinate acceleration of the tree from my perspective. Therefore, the tree is probably in an inertial reference frame.
So by probably, at the end of this, you're still unsure if the car moved. So you're on Pfinky's side. You don't know if it's the car or the tree moving, even with this proper acceleration.
Well,
so you're
you
going to
can
tell me
tell
we don't know
the relative motion.
We don't
That's
know
all
if
you can
the car
tell.
or the tree moved. We don't know if the car or the tree moved, but you guys are going to sit here and tell me the satellite moved. All right, that's brilliant.
You're making no sense, Jeremy.
I know I'm not making any sense because I'm steelmanning two different Globers at two different times. I got one guy telling me we know a satellite's moving, and another guy telling me we don't know if a tree or a car is moving.
No, you're straw manning, you're not steel manning. So when you say we know a satellite is moving, what do you mean by that? If I sit here on the ground, I can measure the velocity of the satellite relative to me. I know it's moving.
Did you want the answer to that,
me,
or
right?
did you want the answer to your thing, or?
Oh, sorry, you go. Yeah, I thought you weren't answering. Go.
Moving means it was at point A, and now it's not at point A, it's at point B, which is what Phil was trying to say the satellites are doing, except in relativity, when you don't have proper acceleration, you can't know what's moving. Einstein even said it, it's just as likely you fell towards the ground as the ground fell up towards your face if you trip and fall on the ground, because there's no proper acceleration there, which is what you don't have with a satellite. You do have it with the car. You don't have it with the satellite. So if you're saying we don't know if the satellite, if you're saying we don't know if the car or the tree moved, you have no business telling us the satellite moved, because it's in the same, it's even worse off than the car, because at least with the car you have proper acceleration. You have nothing with it with an orbiting satellite.
Yes, we do.
A free falling satellite.
Do you drive a? Can you feel? Do you know when you're driving a car?
No, apparently we don't know when we're driving cars. We have no idea if trees.
You don't drive a car.
Move in us, or we move into trees.
You don't know when you're driving a car.
When you have a car,
you're totally
if you
oblivious.
crash into a tree. Can you hear me, Phil?
No, I'm just when you drive down
Phil,
the road.
Can you hear
do you
me?
know when you're driving down the road? How do you know that you're driving?
No, these guys have been arguing with me for weeks. Can you hear me, Phil? Can you hear me?
I can hear. I can hear you. Yeah. Yeah, I can hear you.
These guys have been arguing with me for weeks.
Yeah.
Yeah, I don't know why you're interrupting. Yeah.
Okay.
Can you just let me go, or?
Yeah. Okay. No,
Can you let me go, or what's up, bro?
You.
Just stop interrupting, dude. Just stop
interrupting,
man. Just go on mute for a second, Phil.
You don't want to know?
Can you stop interrupt? I've been trying to finish a sentence for a minute. Can you just stop and let me go? These guys have been arguing with me for weeks that when you are driving a car, I know how to drive a car and I would know the answer to this. But they've been arguing with me for weeks that when you are driving a car, you don't know if the tree moved into you or you moved into the tree. Or sorry, you don't know if you moved into the tree or the tree moved into you. So I know how to drive a car and I would know I drove into the tree. All your Glober friends have no clue what's going on.
Okay, well, I'm not in there because I know when I'm driving a car because I put my foot on the gas and it goes.
Me too. I feel you. I know. I hear you. I'm with you on that. We agree.
So when I put the gas in the rocket and it goes up, I know the rocket's going up. When the rocket's going around, orbiting the Earth, I know it's the rocket's going around because I put the gas in the rocket and I made it lit it up. So the rocket's going around. So I know the rocket's going. And then when the rocket lets the satellite go, I know the satellite's moving because it's going the same speed that the rocket was going. Now we let the rocket fall down. We let it slow down, and the satellite keeps going. So that's why we know that the satellite's moving.
Phil. That's fine if you want to say that. I'm just pointing out the hypocrisy in the other people's arguments about the tree and the car scenario, because we've been arguing it for a long time. I would agree with you that if we put something in motion and we did the thing, we know we're doing it. We know we're driving the car, Phil. I'm with you. Team, we know we're driving the car. I'm just using this example. I'm just using this example of now you're coming with, we know what's moving, right? We know that satellite is moving, right?
Yeah, so let me explain to you what I think they mean, right? Let's say, for instance, two passengers. Have you ever been inside a Maybach or a Rolls Royce? You can't feel it move. You just can't feel it move, right? They are that quiet. You can't feel it. You know that you're moving, but because you look outside and things are whizzing past you, but you can't feel it if you're in one of those cars. And now when you're at the lights and two people at the lights, and when one of them stopped and the other one's moved, you know it's impossible. It's practically impossible to tell who's moving. Sometimes it looks like if I'm sitting in one of those, it looks like I'm going backwards. It's not me going backwards, it's the other guy going forwards. It just feels like
Yeah,
it.
but this
I
isn't.
can't feel it.
But Phil,
It's
this
what I
isn't.
look. That's what they're talking
But
about.
Phil, this isn't what Phil. This isn't what the Globers were saying. That if we have a tree in a car, and you were to start driving into the tree, they're telling you you have no idea if the tree's moving towards you or you're
No, so
moving
what they're
towards the
saying,
tree.
it looks the same. It looks
So
the same. If you didn't know anything about trees, like trees can't get up and move. If you knew nothing about trees and you knew nothing
you're
about
making
cars,
my
you were just
argument
sitting
for me.
there looking at it. You would think that the
You're
tree
making
was
my
coming
argument.
towards you.
We know better,
If
though.
you were
Me and
sitting,
you know better. We
yeah,
know it
if
could
you were
look
sitting
like
in one of
something.
those,
We already know it could
yeah,
look like something. We went over this. Hold on, Phil.
yeah,
I went over
yeah,
this
that's
with the
right. So
Globers. We know it could look like
if
different things from different vantage points, but me and you know that the car moved into the tree, right? Because we know how trees and cars work.
yeah, because we know trees can't get up. That's why we know that. That's what we know. That
We're not in
exactly.
Lord of the
We
Rings.
we
Are you
have
sure we're not in
we've
Lord
got
of
a
the Rings?
reference.
Wait, did we scientifically prove that?
But if I
Phil, are you
didn't
sure we're
know
not in Lord of the
what a
Rings?
tree was, if I was an alien and I didn't know what a tree was, and I didn't know what a car was, and I was sitting in a car watching the tree, watching move, I wouldn't know if the tree was coming towards me or whether I was going
With an
towards the car
atomic
because I
clock, you
wouldn't be able to
would.
feel the movement.
With an atomic clock, you would know.
How? How would I know? I don't know that trees can't
Time
move.
dilation. You could have a
No,
mechanical device,
I can't tell it. Time
attached to
dilation is
4 atomic
no time.
clocks and move them out
That,
from the center, and
time
then
dilation
stop
only
them
works at
all
very
simultaneously, mechanically stop them simultaneously, and then read
time
them.
dilation. You can only measure time dilation when you're very, very close to the speed of sound. Okay, otherwise it's impossible to tell.
Jeremy, it's impossible with this guy. I'm sorry. Ask a question
You
and he
have to be
talks over
going
the
very,
words,
very
Jeremy.
fast.
You hear what I'm
You have
saying?
to be
I'm
going.
sorry. That's why I try to get in quickly with you. It's not because of you. It's because of the other people like this.
All right. You have to move
You're like a
very,
Beastie
very
Boys
fast
song. It's
for
sabotage.
time dilation to make
Sorry,
any
Phil, go ahead.
difference. Okay, for time dilation to make any difference, you have to be going very, very fast. If you have a look at
No,
the
there just needs to be a
Lorentz formula,
differential. There just needs to
if
be
you
a
look at
differential, bro.
if you look at the Lorentz formula, being able to work out what that difference is, unless it's really fast, it's nearly impossible. It's like 20 decimal places away. You wouldn't be able to tell. There's no instrument that could measure it.
Oh well.
Okay, it'd have to be going really fast.
Nah, dude. You could be going as fast as an airplane,
Well, you're
bro.
clearly not. You're clearly not familiar with the Andromeda paradox, then, are you, Phil?
Or the Etvos effect.
Phil? Are you familiar with the Andromeda paradox?
No, I don't know. What is that? I'm not.
It's when you
I'm
could
not
be
an
going
astronomer.
really
I'm a
slow.
practical physicist. Okay.
This is more of an Einsteinian thing than an astronomy thing. There is some astronomy involved with it, obviously, but
Yeah.
you
So
could be
it's
going
not in the.
really
Is
slow.
is the Andromeda
You
thing
could be going
fixed in the
really
firmament?
slow.
Is it fixed in the
You
Please
firmament?
could
tell
be
me,
going
Jeremy, the
really
Andromeda
slow.
thing.
I'm trying. I know. I'm trying. You want to hear the Andromeda paradox, Phil?
Yeah. Go ahead.
You could be going very slowly. Somebody could be standing still on a sidewalk. And then another guy could just be walking, casually walking by him. And if they were to observe the Andromeda galaxy, one guy might say the Federation has left to attack. And the other guy might say that the Andromeda Galaxy Federation is still deciding on whether to attack. So one guy would observe the ships heading out, coming to Earth to attack us, and another guy would observe, them debating on whether to attack us or not.
Okay.
A second before.
There's our time
You talking about
dilation.
the thought
Boy,
experiment by Roger Penrose? That's what you're talking about.
Penrose was deeply in. Penrose is the shit, bro. Yeah, Penrose.
That's who you mean. You're talking about the stuff by Penrose.
The Andromeda paradox. Yeah, Penrose was on it.
Yeah. Two people walking past each other on Earth can disagree by several days. about what's happening right now in the distant Andromeda galaxy, purely because
Yeah.
of their difference in velocity?
Yep.
What's the
Yeah,
issue
very
with that?
slow velocity though, very slow. You said you had to be going very fast. I was like, oh no. You could actually have this happen and be going very
Yeah,
slow.
all right. Do you understand that when things are really, 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 really far away, they look like they could be going slow, but they're going very, very fast? Do you
I know, but
understand
it's
that?
two
For
people
us,
going. It's a guy going slow. One guy's going slow, and what? It's not anything close to the speed of light. You can have this time dilation effect by going very slowly relative to another thing. You don't
it's
have to be
just a
going fast.
perspective thing. It's just a
You don't
perspective
have to be
thing.
going
Okay.
fast like the twin paradox. You could actually be going very slow and still have this happen.
Yeah.
Can you just
I
concede
get
The
that
it.
you were
light hitting
wrong
our
and you
eyes
don't?
thing.
Can you just concede that you were wrong and you don't have to be going fast for this to happen?
No, you need to be going fast
Oh
to
God.
measure it. Do you understand? Do you even know the formula for it? Do you know Lorenz's formula? 1 over the square root of 1 minus v squared over r squared. Do you know
Okay,
that
so you
formula
couldn't
at
measure it.
all? Do you know that
You're
formula?
telling me we can't measure it? You're telling me we can't measure it when we got one guy saying, "Oh, it's this time there. They've already left to send the ships." Another guy saying, "No, they're still deciding on whether to send the ships." You're telling me we couldn't measure the time between when the guy does actually see him send the ships between when the
Look,
guy said
you,
they had already sent the
we're talking
ships? I
about
mean,
we're talking
it's
about
not like
looking at the
a point for you
we're not talking
to
about
concede
ships. We're
on. You can
looking at
just concede
paradox.
that
We're
this
looking
does
at the
happen.
Andromeda.
Phil, can you hear me?
This is a thought
Phil,
experiment, okay? It's not a
I
real
know
thing.
I'm trying to walk you through it.
I already know it. It's a thought experiment. Okay?
Wait, a few minutes
It's not
ago
real.
you didn't know about the you didn't know
Yeah,
about now you
I
know
didn't
all
know
of it?
what he was referring to. Had he
Just
said
because
Roger
you know a
Penrose,
formula? Come on.
had he said Roger Penrose, I would know exactly what he's talking about. But he didn't say that. Okay, that's a thought experiment. Okay,
It's
it's not a
not
real
relative
thing.
who came up with it. It's completely irrelative. It works off of
It's just a thought
it
experiment.
works
It's not
off
an
my
actual
man,
thing.
bro. Can you stop interrupting me, please, for the love of God? Like I already
Go.
have a bad connection. You interrupting me just makes it that much worse. Like, are you
All right, go
interrupting
on then.
because I have a bad connection, or should I just
All right, go
stop?
on.
No, it's because you're saying something he disagrees with and he has to shout. Professor Phil, could you not do that? Could you just like wait
Okay.
until I'm finished, please?
Okay.
It
Go
can
ahead.
happen on a very. I'm gonna. Thank you. It can happen. This time dilation thing can happen when you're going at a very slow speed. You don't have to be going near the speed of sound or whatever. You could measure it if you wanted to. The guy could say, "All right, let me see how long till my thing catches up with your thing," and then they would know how much they were off. This ain't a
Okay.
hard thing to
All right.
conceive.
All right. No, what you're talking about is a thought experiment. It's not reality. In reality, the thing that you're measuring has to be going very, very fast for there to be a difference in time, so we got time dilation. Things that are here, you can't make things go fast enough here. Satellites barely. The time dilation in satellites is, even though they're going so fast, is very, very small. But time dilation that happens in space, where you've got stars, they are a long, long way away, but they're going very, very fast. The Earth going around the sun is going pretty fast. Okay, we
Isn't
can't
it too
make
fast?
rockets go that fast.
Isn't it above the Earth and the speed of light?
I mean, you guys don't know how fast Earth is moving. You don't have any proper acceleration. You only have
Yes,
coordinate
we do. Of
acceleration.
course, we know how fast the Earth is moving. We know
You
how
have no clue if
Earth.
this Earth is actually stationary. Bro, come on, man.
Yes, we do.
Matter got to
You
turn
you
energy.
don't you have no proper acceleration with the Earth because it's in free fall, just like your satellite. So there's literally no way to tell what's moving when you don't have proper acceleration.
All right, let me explain that to you. All right, we look at this. We look at the sky. We see where we are in relation to. First of all, we measure all the things that are around us. right? So we see where's Mars, where's Saturn, where's Jupiter. We look at where's Venus, where's Mercury. We can see they all going around the sun. All of these things are going around the sun. We can see them going around the sun. We measure it. All right. Even back in the 1700s, they
No,
measured these. They measured these
no.
things. Okay.
They're
All right. You got
stationary
to
and the
let me
sun's
finish
going
now.
around it. And no.
Now I haven't finished yet. So now what we do is we have a look at them, and because we know how fast they're going around the sun and we know how they're going around the sun, we're able to measure us when we look at them relative to them. So we can say, well, we know how fast they're going. We know that the sun is stationary over there. We know how fast that they go. So we can tell that we're going around the sun too. Okay, we can measure it. That's how we know
All
we're
right, let
going
me
around. And
ask you a
not only do we
question.
know how we're going around the sun, we can measure how fast we're going around the sun.
Okay, let me ask you a question, Phil. When we
Yep.
drop something, do we know if the object moved to the ground or the ground moved up towards the object?
Were you born day before yesterday? Of course you know that
Well,
the
what if
object
it's
fell to the
going at
ground.
a constant
Hold
velocity and there's no
on.
acceleration?
It can't go at a constant
God
velocity.
damn it. But hold on, Phil. It's funny you asked if I was born yesterday. Does that mean obviously the object's moving towards the ground and we know that?
Yes.
Well, I've had a PhD, John, a PhD physicist, and he was debating me for a very long time, and he was claiming that you don't know what's moving, and it's silly to even ask which one was moving. So I don't know how you know this, and the PhD physicist is
I
going
am
against you.
too.
I mean, I don't know if
I
you're.
am too. I'm also a PhD physicist, so I do know. Okay. All right. The
You
thing
just need a
I
reference,
see when
Jamie.
I drop something, it falls to the ground. I got something here. I can drop
You're
it.
not steel man
Falls
in
to the ground.
mainstream physics now, though. I know, we
What if
know,
it's
but you're
lowered
not
at a
steel man
constant
in mainstream
velocity?
physics.
I told you, I'm a
Don,
practical
please,
Hey,
dude.
physicist, right? I can see that it fell to the ground. It was there on my table, and now it's on the ground. You have to be some kind of
I know, but you're
nutcase
not
to
steel
see if it's
manning main
to think the ground came up and fell on top of it.
I know, but you're
Okay,
not
I
steel
know that.
man
Go
in
on.
mainstream PhD level physics. Are you
I
done,
I
bro?
don't
Or I
care
thought you were
about
done.
mainstream people. Why do I care about what
No,
other
don't
people
don't
say?
respond to what I was saying. I was halfway through my thing, bro. You interrupted. I didn't know if you were done or not. Like, I'm just trying to figure out what's going
Okay,
on. Are you done?
all right. Yeah, I'm done. You go ahead now.
All right. I'm just saying you're not steel manning PhD level physics, which is what I'm sure this would all encompass, the highest level of physicsry. You're not doing it. Like I said, I've debated with it. Unless that guy was wrong, unless the PhD physicist was wrong, and we do know if that is the object moving down and not the ground moving up. Was he wrong and you're right, or you know what's going on
He's
here?
definitely wrong. If he can't tell if he dropped something, whether he dropped it or the ground moved up, he's an idiot.
That was actually my position. I didn't want to like say that out loud to him. I might have said that out loud. I'm very inappropriate sometimes, but I would agree with